2000, Awqaf South Africa was pioneered as an institute of Waqf and the empowerment of communities. South Africa faces a diverse set of challenges with a high unemployment rate and a stark divide between rich and poor, where electricity, hospital care, and water shortages plague communities, and where lack of education hinders progress. Okaf South Africa is a catalyst for change. As a charitable endowment receiving organization, Okaf invests endowment funds wisely and ensures that only the income generated from investments is used to fund a variety of community development projects. We are excelling in all that we do with the highest standards of ethics, integrity, and sincerity of purpose. From masjid development, imam empowerment to sports development, orphan support, food security, and surgery support, Awqaf South Africa is paving the way by investing in the future of communities and uplifting generations to come. Awqaf South Africa, creating a legacy of hope and
There we go. What a way to start the program. My name is Hassanin Abdullah from Okaf, South Africa. You are most welcome to the session. This is the Okaf SA and Falaah College Grade 12 Physics Online Maths Workshop in preparation and to prepare our grade 12 learners for their physics. Okaf SA is a community based organization and we are involved with projects um, that are aimed to uplift our community under the banner of our health program. We restore people's eyesight through a cataract program. We we assist water stressed communities by providing boreholes. We set up PC labs. We host rugby, cricket, and soccer tournaments. And as part of our focus in education, we are known for hosting our grades 10, 11, and 12 maths workshop. And for the first time, we are doing this jointly with Al Falah College. Al Falah College, this is part of the CSI outreach, where a cohort of learners are located at the school, and we will be going through a physics workshop during the course of the day from 9 all the way to 3 o'clock. The session is hosted on Okaf's YouTube platform. Please subscribe to our YouTube platform. We've got some good programs that'll be of benefit to you. Please share this with your friends. Let us know in the comments from which province you are connecting to us from, as well as the school that you are connecting to us from. I'll be myself and Khalid will be the continuity presenter for the session for today. Mr. Dikesh will be the facilitator. We really love to thank Mr. Faisal Kathri and his team for the excellent service. They are the AV service provider assisting us with the details in the background. Now we're going to be calling on an educator from Al Falah School by way of introduction. So I'm going to be calling on Mr. Wahid Hussein from Al Falah College. He's going to be doing an introduction, like we said. This is an initiative by Al Falah College and Okaf South Africa, more so Al Falah College, and this is part of the CSI outreach to assist learners across South Africa. So I'll be calling on Mr. Wahid, and he'll be giving us a way of introduction. Assalamu alaikum, Wahid. Take it away.
Take it away. Assalamu alaikum. Can you hear me, Asnain?
Loud and
Loud
clear.
and clear. Gee, lovely. Assalamu alaikum. Good day to everyone here today. Look, on behalf of Al Falah, I just would like to extend a very warm welcome to all of our students, teachers, and schools joining us today, both in person and via live stream. It truly is a great honor and privilege to host this special extra lesson program as we support our matric students during this crucial period leading up to their final examinations. Today is particularly exciting as well, as we are live streaming our physics lessons for the first time. This step comes in response to an overwhelming demand from students who are eager for additional support in this challenging subject. By offering these sessions online, we are able to reach even more learners from across various schools, providing valuable assistance as they prepare for their matric examinations. As you know, these matric exams these matric examinations are a milestone, and these matric examinations are quite a milestone and a significant milestone. And our aim with these sessions is to equip you, dear learners, with the knowledge and confidence to excel. Whether you are here in person or attending online, we are thrilled to have so many learners united in the pursuit of academic success. I would also like to extend a special vote of thanks to Mr. Haribans, who has been teaching since before I was born. With many decades of experience in education, his expertise in physics is unquestionable, and we are incredibly fortunate to have him facilitating today's lessons. His guidance will no doubt be invaluable to you as you navigate through the material. Thank you, sir. A heartfelt thanks also goes out to Awqaf SA for their collaboration and support in making this program possible, allowing us to extend our reach and impact students from various schools through live streaming. Let us all make the most of this opportunity to learn and grow together. May Allah grant us all success and make this a beneficial experience for each and every one of you. Thank you very much.
There we go. That was educator Mr. Wahid Hussein from Al Falah College. Please let us know in the comments where you are connecting to us from. Please share some love. We're going to put your comments out on the screen there. Subscribe to our YouTube platform. This session is hosted on Okaf's YouTube platform, so you can refer back to this and pass it on to your siblings when they do connect and they are in grade 12. So yes, this is a very important initiative and a project. We really need learners to perform well and excel in physics and mathematics. These are the requirements and part of a foundation for future careers in STEM. We really need some more quantum scientists, engineers, doctors, you name it. So we are in your corner, and class of 2024, the success. This is to your success. So we're going to be calling on Mr. Niresh Hari. He is a facilitator. He's a veteran educator. He's got lots of
Lots of
experience
experience
in this. So we're going to be handing over to him, and he's going to be taking the
It's going to
program.
be taking the program.
Hello, everybody. Welcome to this session. I just hope it won't be too lengthy for all of us, but remember our goal is for academic excellence in one of the major challenges in the education system, physical science. But it's not really a challenge if we have our mind, a certain mindset where we can excel in the subject. Even if we are underachieving, you can go far places. I mean, at the end of the day, we are now coming to we can call it the race. The Comrades Marathon is almost over. We are about to get to Poly Shorts, the major uphill battle of the race. And I'm sure all of us are willing to finish the race and start our future careers on a positive note. If we look at our program of schedule today, we have a starting time of 9 to 10:30. And in that time, I will be doing mechanics, which is physical science paper 1. Thereafter, we'll have a half an hour break and come back and continue paper 1 between 11 and 12:30 with waves, sound and light, and a little bit of electricity and the introduction of paper 2, where I will do the multiple choice of paper 2. What we have in our booklets in front of us are 4 examination papers that have been set, and these papers will be revised on 2 days. Today we'll do 2 papers, paper 1 and 2, and tomorrow we'll do the next 2. And hopefully then we can finish up, and obviously there will be time for questions and answer sessions. Right, to get started, if we look at our booklets, now unfortunately the booklet that we have available here, is it coming on yet? Yeah. This one is not. We'll go to a preview, okay? Sorry about that. Just let me get to the preview. Right. The booklet that you've got is a reduced version of my one at the top here. Unfortunately, I think some of were skipped accidentally due to errors in that machine, the copying machine. But what we can see here is the actual heading of the paper is on the 3rd page. Right? It says the pre-trial exam, physical science paper 1, and 1.3 is the multiple choice, but alongside it, you've got question 10 as well. And 1.8, 1.9, and when you come to the front page, well, this is the paper for tomorrow. This is the paper that I will start with, right? If there are issues with the numbering of the paper, I will explain it with the exam paper that I have. This is the entire booklet. And then paper 2 will be done in the next half of the session. There's paper 2 starts here, okay? And with question 2, question 3, and so on. But let's make a start. 1.1, if we look at our question paper, right? 1.1, 1.2 is missing in your one, but if we look at it on the screen, what we find is examiners will definitely start with definitions in the exam paper. What is paper 1 or 2? And 1.1 and 1.2 relate to definitions. The net force acting on an object is equal to ... of the object in the direction of the net force. Now that is the statement of Newton's second law in terms of momentum. Many of us learn Newton's second law in terms of F net is equal to ma. But we must bear in mind that Newton himself, 400 years ago, wrote his law in this fashion. So we must take this into account when we are studying for the final exam from the guideline document 2021. And your answer here obviously is C. To complete his statement, the net force acting on an object is equal to the rate of change in momentum. Many of us leave out the word rate, and then that becomes the word impulse. So please do not confuse the word impulse with the rate of change in momentum, which is called F net. Right? It's in the CAPS document. Please go through it very, very carefully. The statement of the law, we look at the wording of the English in order to award marks. Number 2, again, a definition. This is something that we all should be getting right in sciences. Level 1 question. The physical quantity that's described as a measure of the resistance of a body to a change in its state of motion is known as inertia. Right? Inertia is the laziness of an object in simple terms. Right? Again, this is a definition. There's another definition related to the word inertia. It is called mass. When they asked you what is mass in primary school, you said it's the amount of matter in an object. But in terms of grade 12, mass is a quantitative measure of inertia. If they ask you the quantitative measure of inertia, it is called mass. When they ask you the physical quantity, the resistance of a body to a change in its motion, it is called inertia. Think of it, the laziness of an object, the resistance of an object to change what it's already doing. Right? 1.3, the diagram below shows a parabolic curve of a stone that's projected vertically upwards. This is called projectile motion. Right? Projectile motion, the definition did come out in our trial exams in KZN. What is a projectile? What is projectile motion? It is described as motion given to, a velocity given to an object initially, where the only force acting on the object is the gravitational force. So you must give the object an initial velocity first, and then the only force acting on it is the gravitational. Okay? So, in this question they're asking you, at which one of the positions will the magnitude of momentum be the greatest? Now, what they've done here is they've married momentum with velocity. Okay, I'll use a black pen. Right? So momentum is a product of mass and velocity. The mass of the stone is constant, so momentum is directly proportional to the velocity. Now, in which part of this scenario will the velocity be greatest? Position 1, 2, 3, or 4? Where the velocity will be the greatest? It's an easy question. At 4. So definitely the answer is D. Right? Because when an object is about to hit the ground, its velocity is the maximum. After it hits the ground, nobody knows. We're not worried about that. Because we are worried about falling bodies, free fall, where the only force acting on the object is gravitational. Right? W, O, F, G. Right? Again, this came out in the KZN trial paper. Right? I had a feeling it will come out. My learners knew it will come out, and they all had it right. They asked you all to draw the free body diagram for this, and this was the answer. Okay? You exclude air resistance in all equations of motion. 1.4, two cars P and Q moving in a straight line have the same momentum. The kinetic energy of Q is greater than the kinetic energy of P. Okay? Which of the following regarding the cars is correct? Right? Again, multiple choice. If you're looking at these questions, two cars P and Q in a straight line have the same momentum. You can let the momentum of both cars equal to P. The kinetic energy of Q is greater than the kinetic energy of P. That means it's either velocity or masses that are different. Right? I need to just escalate this a little bit. Right? If we look at my multiple choice here, okay, the answer for 1.4 is A, right? Now, why is it A? Because as I said, if the momentum is constant, mass and velocity can change. It can change in both cars. So when you work this out using these two equations, P is equal to mv, and P is constant for both cars, and kinetic energy is half mv squared. you find that you come to the answer of A. Right? 1.5, the net work done on an object increases its speed from rest to V is W. Right? So the examiner is telling you W net is equal to delta K, which is equal to Kf minus Ki. These equations do not help us in the matric exam paper. They don't help us at all because the examiner is not going to give you a value here and a value here. You have to work these things out by factorizing it. So at the end of the day, when you factorize K, you would say half mvf squared minus half mvi squared. Okay? And when you factorize that at half mvs squared and half mvi, is that okay?
I have a question for you.
There's a question? Okay.
You might have to rewrite each question out because our learners cannot see the questions. The text is way too small. So for each question, you're going to have to rewrite it with your Koki pen, and we're going to have to go through the answers in that way. Your text is way too small. It is minute and tiny. Our online code cannot follow with the lesson. Okay? Okay?
So if you zoom in here, then they'll be able to see it. Can you see that, sir?
Okay, that's a little bit better. We'll just get some of our online code. Let us know.
Okay, is that better?
Let us know. Our online code, let us know in the comments if this is good and can work for you. We have heard your pleas. Please hit us up in the comments.
Yeah, it's better there.
So, why am I tilting this thing?
You know, if you just move your paper up and down.
Okay, that looks
all
a
right.
little bit.
You can see that now online, sir?
Fantastic. Go for it, sir.
All right, okay. Now we're on 1.5, unfortunately. The net work done on an object to increase its speed from rest is V. 2V is W. How much net work must be done on the same object to increase its speed from V to 2V? Now this is a tricky mathematical question. And the only way to work it out is using this equation, but factorize it. Now, initially you have the speed going to V. Vi is 0 and Vf is V, right? So when you're substituting here, you would substitute half mv for Vf squared minus 0 because Vi is 0, that cancels off. And the examiner is telling you half mvf squared minus 0 is called W initially. Now, when you increase your velocity from V to 2V, how much net work must be done on the same object to increase it from V to 2V? So, V and 2V become your Vi and your Vf. Right? V to 2V become your Vi and Vf. And when you substitute that into the equation that you've just used as the new scenario, you will end up with the alternate answer. Now, this is a bit tricky because if you look at the guide or the alternate answers, the A, B, C, D. A is W, B is 2W, C is 3W, and D is 4W. And the memo is absolutely clear. The answer will be 3W. What would happen is many learners will come up with the answer of 4W. But if you read the English in the question, how much network must be done on the same object to increase its speed from V to 2V? If you subtract the two W's, the final work and the initial work, you'll end up with 3W. Because many learners find the answer is 4W, which is not the case. Right? It's a trick in maths that the examiners use to employ it. 1.6, right? Let me try and get this down. 1.6 again. This is application in English. You got to know this Doppler effect, which is not the application of a Doppler effect. Blood flow meter, I think we've all heard of that. Detecting the heartbeat of a fetus, we've heard of that. Measuring the speed of an approaching car, it's called Doppler radar. So 1.6, the answer is definitely A. A light meter does not use the Doppler effects. Right? Again, straightforward, level 1 question, we should be getting marks for that. 1.7, two identical metal spheres on insulated stands carry charges of -q and 3q respectively. When the centers of the spheres are d apart, the spheres exert an electrostatic force of F. Right? Now what you're looking at here is the spheres already, they are telling the force is called F. The spheres are now made to touch each other and brought back to the same positions as before. The magnitude of the electrostatic force of the spheres will now be in terms of F. Now, if what they are saying is, again, this is a trick in mathematics. You must be very careful with this question. F is equal to K Q1, Q2, all over D squared. They are telling us that all these variables is equal to F. So I call this the old scenario, what the examiner has given. Now we're going to work out the new scenario. The new scenario is, he says the spheres are allowed to touch. Now when you touch the two spheres, you're going to get electron transfer from one to the other and a new charge forming, which is grade 10 work. So new charge, you first have to calculate, is equal to old charge minus Q plus 3Q divided by 2, which becomes 2Q all over 2, which is Q. And that is, each one has a charge of Q. But at the top, these charges are Q and 3Q. They have decreased by a factor of how much? It was 3Q squared. 3Q times Q is 3Q squared. Now it is Q and Q, which is Q squared. So by what factor has it dropped? By 3. So what will your answer be in terms of multiple choice? But D has not changed. Did they say D changed? Same position as before, so D has not changed. So what is our answer in terms of the multiple choice? 3F or 1/3 F? 1/3 F. So the answer definitely is, and if I look at the answer here, I did it before, it is B, there it is. So this is Coulomb's law. Instead of asking you the law, they have asked it mathematically. Now these kinds of questions, learners, must come out in your paper. They have to come out. They're going to manipulate the numerator. Remember, the numerator is always directly proportional to the product of the magnitudes of the charges, but inversely proportional to the square distance between their centers. That's what that means. The force, the force between the two charges is inversely proportional to the square distance between their centers. Okay? So this cannot be a level 1 question. This is definitely level 2. Right? 1.8, we're coming to electricity. Right? A learner in the circuit below, the battery has an EMF and internal resistance of R. Right? Now, what you can see about the circuit, there are no series users. If we have to draw the current flows in that green section. When it comes to here, the current will split, it will come to here. The current will split into 2 branches, a top branch and a bottom branch. And it flows through and meets here, if that switch is closed. So the only section where the current is the main current is the section here. That is current total or current in series or the main current. That is the only section. Where I am ticking, that is the branched current. Now you have to know this in examination. And this is a bit of a nasty question because many learners think that there must be users. These are called users. These are users in parallel. But if you look at that squiggly section, there are no users in series. So the voltmeter reading here, this one, is actually V external, which is also the parallel voltage across the branch. It's a very special case. It's the parallel voltage of the branch. So that's V external, that's V or V parallel. You must know that. And we know that the EMF is always equal to V external plus V internal or V lost. Now this is background information before you have to start attempting this question. Otherwise you'll be stuck. Switch S, with the circuit below, the battery has an EMF E, the resistance R. When switch S is opened, now when it's opened, it means we block that section. There's only a resistor in series. Oh, the pen disappeared there. Right, we block it. You must do that in the metric exam as well. Take another pen of yours and block that thing. So now you see the current can't split. There's only one main current in series. But now when you close that switch, you get a parallel branch added. How do the readings on the voltmeter and ammeter now change? Now that ammeter is reading I total and the voltmeter is reading V external. You see, the examiner did not tell you that. He just told you that the readings will change. And the answer definitely for this question is, if you adding an extra branch, whenever you add an extra branch, you always talk about these two things first to get your answer. R total and I total. And they are always inversely related, always. So when you add an extra branch, R total will decrease. I total will increase. You only get 1 mark for that, 2 answers, if it was an explain type question. Then you go on to this equation, total or EMF is equal to Vx plus V int or V lost. Now V lost, you can factorize it as I times baby R. And that is where you get your answer now. If I total increased, this one here, V lost will increase and V external will decrease. And the only answer that matches that is B. The ammeter reading increased, correct, and V external decreased, correct. There's it. So whenever you ask a question about V external related to the ammeter in the main circuit, you've got to go this route. Step 1, R total, I total. Step 2, look at EMF is equal to IR. You factorize the equation in the data sheet and call it Vx plus V int. This is I big R, that's I small r. Okay? At 1.9, a learner lists the following factors that affect the magnitude, means value, of the current or amount of current induced in an AC generator. The number of turns, the strength of the magnetic field, the speed of the rotation, which again, this is theory, learners. We have to know this answer. We got to learn our theory. Factors influencing the strength of the current. Now, is this learner correct? Would all 3, which of the following combinations are correct? 1 and 2, 1 and 3, 2 and 3, or 1, 2, and 3. That means the learner says, we are correct, all 3 factors are correct. What is the best answer, the option? Which is the best answer for this question? It's theory level 1, we've got to know it. All 3 factors influence the strength of the current. Now again, this question did not come out in our KZN paper. It could come out at the end of the year. Whenever you got a generator generating current, these are the factors that can increase the current strength. Increase the number of turns. You increase this, you'll increase the I total. Increase the strength of the magnetic field by using stronger permanent magnets or cylindrical magnets. Again, English is important. increase the strength of the magnetic field is marked wrong. Increase the strength of the magnetic field by adding stronger magnets is marked right. So many learners write increase the strength of the magnetic field. They don't tell us how, so it's marked wrong. The speed of rotation, increase the speed at which you rotate the coil in the magnetic field. You can't just say, write down the speed of rotation of coil as a factor. Rotate the coil factor, accepted. Increase the speed of the rotation, accepted to increase current. You can't just say speed. Many learners write speed, full stop. That is meaningless as an answer. The idea is there, the English is poor. All right, 1.10, multiple choice. This is a graph that appeared in your exam paper, right? This graph appeared in your exam paper recently in question 10. Now, it's called Emax, y-axis, x-axis 1 over lambda, and the unit here will be meter to the minus 1, right? Emax is measured in joules. Now, they want to know the gradient of the graph. The gradient is any two coordinates of this graph. You work it out. The gradient is equal to delta y all over delta x. Now, that is not given any marks in a physical science paper. Why? Because it's maths. You got to tell us delta y is actually delta k max. It's on the y-axis. It's there. Delta x is actually delta the inverse of lambda. And then you got to expand that. K max 2 or K2 minus K1. For example, that's 0.2. That's 0.1. K2 minus K1 all over 1 over lambda 2 minus 1 over lambda 1. And that will give you an answer. So if I ask to calculate the gradient of that graph, this now gives you 1 mark out of 6. Because you didn't tell me what the unit is either. And you also didn't tell me what is this gradient equal to. It's either A, B, C, or D. Now how do we work this out, learners? Because I have never seen this equation in the data sheet in my life. Have you? No, nobody has seen it. How can you pick one of these 4 answers when you have never seen delta k over delta 1 over lambda in your life? And the answer is easy. What is the answer? It's very easy. I think I did it in class. I can't remember now offhand. You have seen it. It's in the data sheet. There's it here. There's the equation. The photoelectric equation. Now, this is on the y-axis. If you go back to the question, it's on the y-axis. So, we need to start writing an equation for a straight line graph in the form y is equal to mx plus c.
Sir?
Yes, sir?
Some learners are saying online you're going a little bit too fast for them to follow. The onliners. So, maybe slow it down slightly just to, so that they can also be accommodated. All right, thanks.
Okay, so this graph, this is a straight line graph. It has to be written in this form, y is equal to mx plus c. Now, when we're writing the graph, we need to rearrange our data sheet just like y is equal to mx plus c. And on the y-axis must be k. So we rearrange this equation. We'll say k max is equal to E minus W0. So now we know that's why we need an mx. There's our C here already. So what this is telling us is the y-intercept. The y-intercept, which is this, is the work function of the metal. We already got that. Now we need to find out the gradient. Now the gradient, there's the gradient here. the x value is not E. The x value is, if we go back to the graph, is the inverse of lambda. But I know E is HC over lambda. That's in our data sheets. I know E is HC over lambda minus W0. But still we need two values here. We only got one. Another way of writing HC is writing it like this, times 1 over lambda minus W0. And if you look carefully, there's it y is equal to m. This is on the x-axis, and this is your y-intercept. So your gradient of your graph is Planck's constant multiplied by the speed of light in a vacuum. You have to take the equation. What I've done is, I've taken the photoelectric equation, written it like the data sheet. Then I looked at what was on the y-axis, which was K max. Right? Once you look at the y-axis K max, you start with that in your mathematics. And that is exactly what I've done. K max is equal to E minus W. Straight from the data sheet, I rearranged it. Secondly, I looked at what E is in the data sheet in terms of lambda, because lambda is on the x-axis. Don't worry about the 1 over lambda. Look for the data sheet and factorize the E. So I factorized the E because I got my Y now. Once I factorize the E, W0, I've got it, mx plus c. So this is now the end of the equation. It has to be the y-intercept. Then instead of writing it as hc over lambda, I did a trick in primary school maths. I extracted the lambda out, but there will always be a 1 over lambda. If you extract it out, there's always a 1 on the top. And then you can see I've got the x-axis on my equation. So if I've got the x-axis, next to it has to be the gradient. Did you all understand that, learners? Was it clear to you? Not clear. Which part is missing or was not clear? The last part. You see, what we have to do, learners, is when you take a straight line graph, every graph in physics has to be written in this form. Y is equal to mx plus c. But what data sheets do, they do not write it as this must be the y-axis. E is on the y-axis. This is on the x-axis. That's your y-intercept. They trick us in the data sheet. So what we have to do is look at what's on the y-axis, the kinetic energy of the photoelectron. Look at what's the x-axis, 1 over lambda, and manipulate this equation in order to get this must be the y-axis. You can't put this at the end. You can't put the y-axis at the end here. Manipulate this to match the y and subtract it. Plus w here becomes minus w. So k is equal to E minus w. Then factorize these things. The E, because there's no E on the x-axis. You got a unit meter to the minus 1. But we know E is related to 1 over lambda. Okay? And that's in the data sheet. This equation is in the data sheet. E is equal to hc divided by lambda. It's there. The photon equation. Have you all seen that one before? So where you got E, you took the photoelectric equation, you rearranged it. Where you got E, you put this. Now the hard part for you guys must be this. K max, let me do it again, is equal to E, not E, hc over lambda minus W. So we got Y, mx plus c. A straight line graph must have two values here. But can you see this is only one value? H times c divided by lambda will give us one answer. You're clear on that? Can I make that 2? The answer is yes. Is it next to the c there's a 1? Can you put a 1 there mathematically? On your own. H times c done times 1, does it change your answer? So you can put that 1 on your own. And can you see now you got a 1 there and divide by lambda underneath it. Can you see that? Which matches which axis on our graph? Which axis matches 1 over lambda? X. So where you've got 1 over lambda will be your x. So all you're doing is you took that HC, you separated it into the x-axis, and next to the x-axis, what must you always have in the maths equation? The gradient. And now you proved that the gradient of the photoelectric equation, is equal to Max Planck's constant multiplied by the speed of light. So the answer in the question is definitely A. Definitely A. Right? Now there's another graph that comes out in the exam. They don't put 1 over lambda. They put F. What will that gradient be? It'll be B. If I show it to you, K max is equal to, isn't this equation in the data sheet, HF, for 1 photon's energy, minus W? There's it, M times X plus C is equal to Y. The gradient now is, can you see that? Makes sense now. Now, there's another graph in physics that's also like this. Right? When I come to question 9 on lost volts, I'll show you that the gradient of that graph gives you the internal resistance of the battery. Okay? Using the data sheet again. Okay? Right. Question 2. I know we got to speed up our pace. Right? What I've done previously, right? I have done the memo for you guys. Right? If you look here, there's the memo here. Right, my handwriting, and you guys can copy it on, because if I carry on writing page by page, we're going to be rushing for time. So I'll try and speed up the process. Right, this kind of question always appears in the exam papers. Question 2, Newton's second law of motion. Right, or it could be the first law. Please do not be fooled by this question. What do I mean? What do I mean? The diagram for Newton's first and second law can be the same diagram. The free body diagram can be the same. What will change is the mathematics below. You have to be looking for this, learners. Right? Let's read this together. 2 boxes of masses 5 and 4 are connected to a light string passing over frictionless pulley. The 4 kg box experiences a frictional force of 8,14 newtons. So kinetic friction is given, right, due to the surface, and is pulled by Jane, there it is, with a force of 80. Have they told us yet Jane is pulling with constant acceleration? Have they told us yet Jane is pulling with constant velocity? Have they told us whether the box is at rest although Jane is pulling? Now that is going to determine if F net is equal to 0 or if F net is equal to MA. You must look for those clues. Otherwise you won't know how to equate your mathematical equation either to MA or to 0. It is very important because you get marks for that. And that is called comprehension, learners. Remember, science teachers, unfortunately, I don't think anybody can teach comprehension. It is up to you. You got to look for the word constant velocity, constant speed, constant acceleration, or object in equilibrium at rest. Okay? You got to look for it. The force is applied by Jane makes an angle of 30 degrees as shown. They haven't told us a thing yet. Right? Have you copied the diagram online? I hope you are there. I apologize if I'm going too fast. Once again, state Newton's second law of motion in words. Now, Newton wrote his laws in 2 ways, in terms of momentum and in terms of F net equal to MA. Now, you can choose which one you want in this case because the examiner was not explicit. Right? Now, it is very simple. Convert this into mathematics, into English. When a net force acts on an object, the object will accelerate in the direction of the net force. This net force is directly proportional to the acceleration, but inversely proportional to the mass of the object. Take it from the mathematical equation in the data sheet and put in your English words. F net is directly proportional to the A, but inversely proportional to M. 2 out of 2, right? So far, we don't know if the box is accelerating, eh? We got no idea. Don't worry about it. Don't be frightened. Don't be scared of it. 2.2, draw a labeled free body diagram for all forces acting on the 4 kg box. Now, if you see the mark scheme of 5, how many vectors should you be drawing? 5. Sometimes you might draw 4, although it's 5 marks. But very rarely, remember the examiner wants, the goal is to get the marks for this diagram. Because the next marks is scary for many learners. Agreed? Calculate the tension in the string. Right? That's the one that catches learners. So, the 4 kg box is the box on the plane. Right? This is the hanging block. A hanging block will only have 2 vectors in the absence of friction. The string pulling upwards. Now, why is the string pulling up? This is something I never understood in high school. If Jane is pulling here and the box is sliding this way to the right, it's common sense that this block will be lifted up with a net force. Now, if the net force is upward, there's a string pulling the box and an invisible force pulling downwards. What is that invisible one called? Gravitational. Earth pulls everything down. So your free body diagram there is W versus tension T. I don't like learners writing T. T is not in the data sheet, people. If the alphabet is not in the data sheet, it is marked wrong. Now I know the KZN memo itself had T marked right. You've been warned. It will be marked wrong. T could be anything. Could be type, could be temperature, could be any word. It's not in the data sheet. The word T in the data sheet means this, ladies and gentlemen. It means torque. Torque is a turning force. You are not turning anything in a cable. Please write tension T to safeguard your marks. Okay? Right? Now why? People are wondering why I drew this box. When the examiner asked for the other one. You cannot get the 2.3 right if you don't draw the other free body diagram. Make sense? You can't get it right. You're bluffing yourself. Right, next one. Right, the 4 kg blocks, I'll draw it under here. Or can I fit it on the side? Let's see. Right. Firstly, draw what you see. I see one string on this side. And I see force of Jane, which is given. And I'm labeling it 80 newtons. You label what the examiner gave. Don't try and be too clever. Now, what is the name of this backward force here that's connected, this one here? Tension, isn't it? Is it the same tension as the original tension on this side? So, tension. Now I can write T because I already wrote the word tension here. I qualified my answer in my memo. You must do the same thing. Don't play tricks with your marks. Right. Is this box being dragged on the surface? Yes. If Jane pulls to accelerate it, she's going to accelerate it to the right. She's going to accelerate it to the right. Now, how do I know it's accelerating, but the examiner never said it? How do I know? There's it. The object's being pulled with a constant force. Maybe the examiner should have been better here and wrote the word constant. When there's a constant force of 80, there will be a constant acceleration. Didn't we just write that in the law? Yes or no? When there's a net force on an object, the object will accelerate. That's how I knew it. So, coming back here, that is tension T. Kinetic friction, if the object is moving to the right, kinetic friction will be backwards, right? Fk is allowed because it's in the data sheet. And that invisible weight vector is also there, right? So how many arrows do we have so far? 4. Where's the 5th one? The normal force pushing upwards from the table, Fnon. And many of us are lazy, we don't put the 90 degrees. Please put it. Put the 90 degree, learners. It reminds us never to draw a normal that's at an acute angle. Like even I can't even draw the wrong things y'all do. I'll still draw it with a 90. Y'all guys do some weird things. Please, there will come a point in the marking guidelines soon where they subtract marks for orientation. You can't draw a normal backwards. Doesn't make sense. So if a child draws the normal slightly at an angle like this pen, I must give you the benefit of the doubt. No, that could be another tension from another string, ladies and gentlemen, with components. Try and draw it straight, right? And you get your 5 marks. First mark for that. Second mark for weight. Third mark for what you know, normal. The 4th mark, kinetic friction. Many learners forget this. This is where they lose a mark. They forget that the tension in the string is for both blocks. They are connected. Always remember this, ladies and gentlemen. If there's one string connected to 2 blocks, there are 2 separate tensions individually, but one tension in real life. Because in school, your teacher told you to draw free body diagrams. You block one and draw the other. Then you block the first diagram and draw the second. That's exactly what we've been taught. So follow that rule and you will get your marks. And now from the diagram, ladies and gentlemen, we get our answers for F net sideways and F net upwards. Okay? And I will show you that now in my memo. Right? What you'll see in my memo is when I drew the free body diagram, I also included the 30 as a dotted line. I also write Fx there and Fy here. Now, why do we write in dotted lines? Do not put arrows on those dotted lines. Right? The best way to draw it is draw it separately. Fy, Fx. And don't forget there's a normal over there as well, Fn. Right? Because remember Jane pulled at an angle of 30 degrees. So that force is not horizontal, it's not flat. There will be part of that 18 Newton force upwards and part sideways. Now why is that upward force? Why is Fy upward? Is Jane pulling or pushing the block? So when you pull something, you tend to lift when you pull. When you push something, say I am pushing this pen now. Right, let me move my fingers out of the way. When you push, you're actually digging. Let me try it with the sharpened point of the pen. See, when you push, I might tear the page. Can you see how jerky that movement is? So when you push in, the Y component is downwards, scratching the page. When you pull, you are lifting. So the Y component is upwards. And I taught my learners this. Yes? Is there a question there? No. Fy is F sine theta. Right? The X is your cousin. X is related to cause. Why are you committing a sin? X is your cousin. So Fx is equal to F cos theta. And Fy will be F sine. So what you are saying, your ex-girlfriend or boyfriend is your cousin. Why you committed a sin? That's how you remember it. X is cause. Why you committed a sin? And you'll never forget it now. Never. In an inclined plane, it's the other way around. X, the parallel component is sine, and the y is the cos. Right, anyway. And that's exactly what I've done here now, 2.3. F net is equal to MA. Fx, if you go back here, this block is sliding. So that vector, and tension are the only three that slide the box. But which is the biggest one? The X, Fk, or tension? If it's moving to the right, X. So it's X minus T minus friction is equal to MA, 4A. You can call that equation 1. Now we do the same thing for the smaller block. Right? The smaller block, I'll draw the free body diagram here on the side again for you guys. It was tension, weight, downwards, but F net is upwards because the other block was pulling it up. So there's it. T minus W is equal to F net, which is equal to MA. And T I don't know. W is equal to mg, which is 49. The mass is 5 times, this is 5 times 9.8, is equal to MA, which is 5A. That's exactly what I've done here. But in reality, ladies and gentlemen, let's go back to the question. How many accelerations do you have on the system? How many accelerations, ladies and gentlemen? If the blocks are joined, there's only one acceleration. So there should be only one F net. But I've got two F nets. F net for the downward and F net for the sideways. What you do to the F nets is you simply add them. What you do? And that's exactly what I've done here. I've added equation 1 to 2. And this is what it simplifies as. 9A is equal to 12,142. And A is 1.35 ms squared. Okay? But the examiner did not ask you A, he asked for T. So you take your answer for A and substitute it in one of these equations. Either equation 2 or equation 1. I used equation 2. T is equal to 49 plus 5 times A, which is 55.75 newtons. Now I just want you to be aware of the mark scheme, please. Formula, data sheet. Next mark, correct substitutions on the entire left-hand side with minus signs. Because backward vectors will be negative, correct? No mark for 4A. Your memo in KZN had marks for 4 times A. There's no mark in this case. Why? This was only 5. 1 mark for both these correct. So equation 1 left-hand side, equation 2 left-hand side, there's the tick. So any mistake, the only thing you get right is the formula from data sheet is this. This is national marking, people. Watch out. If you make a mistake in both your equations, you're going to get 1 out of 5. And 1 out of 5 is 20%. You repeat grade 12 on that. Be careful. But what you can score is the free body diagram and the definition. If you go back to the question, that is 5 plus 5. 5 plus 2, 7 out of 12 you can get. And now you can't fail. Make sense? So beat the examiner at his own game. You get that one more mark here. You get 8 out of 12, that's 75%. But you got everything wrong here. You got a B. You got naught after this, you got a B. So use these tactics to beat the examiner. Got it? Right, next. Question 3. Our favorite friend, the gravitational law. A man of mass m has a weight of 126.3 newtons on the moon. Right? The mass and radius of the moon are respectively given in exponents there. The problem is this one. Kilometers. Now I'll teach you a trick. Don't ask why. Just do this. Just take the k out and the 10 to the 3 make it 10 to the 6. Add 3 more to it. You converted it to meters now. What you've done there in your mind, you multiplied it by 1,000. Is that clear? So you take the k out and add 3 more on the exponent. Now you've got SI units. The radius of the moon, right? Maybe I can answer this thing here. Right? I've got some space, I hope. Okay, I should fit it. Right? The radius of the moon is given. The mass of the moon is given. The radius and the weight of the man on the moon is given. Now that's a scary one, the weight of the man on the moon. Because we know W is equal to mg. But this is for us in our data sheet on planet Earth. We don't have the G value for moon. We know G on Earth is given in the data sheet of 9.8. So we cannot use this equation for the moon. We don't know G. We don't know the mass of the man. The only thing we know is his W. So when you've got 2 fresh air unknowns, you can't use the equation, ladies and gentlemen. Did you know that? Many of you will start like this and get 0 out of 6. It's wrong. What we need to do is use the equation given to us by the examiner in the data sheet, which is F is equal to G M1, I'll call it mass of man, mass of moon, I'll call it, okay, write the word moon, all over R squared or D squared. Remember this man, if I have to draw this man of mass M, there's the moon. The man is standing on the moon. So the distance from the center to him is the radius of the moon. Right? The man is there. So that's the distance from center to center. We pretend he's a dot. Okay? We don't draw the real man. We pretend he's a dot. Is that understood? That's the radius. The mass of moon is given. This mass is given. The mass of the man is X. We don't know it. We don't know him. Leave it as X. But we know when you stand on the surface, he's standing on the surface, he must have weight is equal to mg. That weight is the attractive force on that man, on the planet, isn't it? So there's that force here. That force is called the force of attraction of the man on the planet to himself. The planet pulling the man pulls the planet. But in this case, the planet is pulling the man to the surface. Instead of writing F, we can write what? W. That force, because Newton's law of gravitational attraction says, I didn't do the law first. The law, again, there's the law. Convert this to English. Between any 2 objects in the universe, there exists a fat, an attractive force. This force is directly proportional to the products of their masses. It's m times m here. Directly proportional to the product of their masses, but inversely proportional, divide means inversely proportional to the square distance between their centers. So, between any 2 objects that be an attractive force, we call it weight in short. We should be calling it the gravitational pull of the planet on the man. That's the correct way. When you stand on the planet, you call it weight, but you should be saying it's the gravitational pull of the planet on the man. That's what we should be saying. So the word weight and this F becomes interchangeable if the man is standing on the planet. So we put W. I need another page. Okay, I'll do it here. W is equal to, let me get it right. W is equal to mg, which is equal to F, the fat, the attractive force. And then I start with the data sheet. Fat is equal to G, M man, M moon, all over R squared. Let me go back and write down. The weight is 126,30 W. right? The moon is a value, 7.35 times 10 to the 24 or 22. And the mass of the man is x, we don't know. And the radius is 1.74. 1.74 times 10 to the 6. I converted it to meters. Right, learners, before you attempt the question, please have a strategy. Put your values here. And now you substitute. Fat is actually the weight, which is mg. Agreed? But this weight is 126.30. If you look at this question, we're going to end up with a problem situation, isn't it? What's your problem? Mass of man is unknown. What about the other items? Is G known? Yes. Is mass of moon known? Is R known? So do we really need the X for the mass of the man? Yes or no? You don't need it. You don't need it to solve it because we are solving for the mass of the man. So G 6.63 times 10 to the, many learners do not put minus 11, they're putting plus 11. Please copy correctly. Times 7.35 times 10 to the 22 times mass of man, well, I'll call him X in this case, all over the distance 1.74 times 10 to the 6 squared. The trick here was that exponent. Many learners will leave it 10 cubed, leave it in kilometers. Now, what I found shocking when I was marking a matric paper this term, the mass of Earth is in the data sheet. Learners were trying to solve for mass of Earth. Radius of Earth is in the data sheet. Learners were trying to solve for radius of Earth. Now, there's only one reason for that. You have never done homework in your life. There's no other reason. No teacher will never not teach that. And that is sad. That is lack of initiative. You are to blame. And you get an answer of the mass to be 78 kgs, I think. The mass of the man is 78 kgs. Right? There's it here. Right? There are many ways of doing this thing. Right? Right, there's your answer. You can copy it down. Right. If you look at the mark scheme now, ladies and gentlemen, just let me show you. 12 marks was the box free body diagram. 6 marks was the gravitational law. So end of the year, expect 20 marks on Newton. Expect 20. I think the KZN paper had 22 this term. So please expect around 20 marks for Newton. Okay? Must state. All right, question 4, our favorite friend. Right? It's in our booklet that I have printed for you. Question 4 is our favorite friend here, vertical motion. Right? Sandila was standing on a platform. Let me just explain this. Right, let me explain this firstly and then I'll show you the English. Sandila is standing on a platform, right? He projects a stone of 8 meters per second from his hand. It lets go. It rises to its maximum height and then turns in its flight and comes down passing a window that's 2.5 meters from the platform. There's the platform where he catches it again. So the ball actually does a full parabolic motion. From the platform upwards, maximum height, and then he catches it at the same point he started. That's what's written here. Right? Sandila is standing on a platform, throws a small metal ball vertically upwards from a height from a height of 1.370 meters above the ground, yeah, right, into the air at 8 meters per second. For those of you who are copying down, I'll give you a few seconds to take it down, right? The ball passes the top of the building and returns to his hand, which is still 1.73 meters above the ground. Ignore the effects of friction. Now, this is quite an easy question, because what he's actually doing is up and down. Oh, you can't see clearly here on the screen. I'm throwing the pen up and I'm catching it in the same place, right? Sandila standing on a platform throws a metal ball vertically upwards from a height 1.73 meters above the ground at a velocity of 8 meters per second. We are CAPS learners. The first thing we say, down is always. The moment you come to VPM, you all are going to do this. Down is negative for KZN. Right? If you are taught down is positive, then you do it that way. Don't confuse yourself. Right? Most teachers teach down negative. Am I right, learners? Right. The moment you got that there, you write A is minus 9.8. Everywhere in the journey, A for calculations is 9.8. If I ask you to describe A, you say it in English. 9.8 ms squared vertically downwards. It's in the data sheet. You copy it from the data sheet, the answer. Describe A. And you'll see in the data sheet there's no minus sign. I don't know why you all write the minus sign. This minus sign is for calculation purposes. For description, you copy the answer from the data sheet with the word downwards. Do you understand, ladies and gentlemen? Came out in your matric paper this year, this term, many learners got it wrong. They put a minus sign. What is A? Minus 9.8. Not. No marks. That was not a calculation. When I ask you what is A, you write it from the data sheet. It's there at the back. Next. Right, ignore the friction. Passes the top of the building. Right. We've got everything. Number one. With what velocity? Velocity means you must put a direction. Does the ball strike Sandile's hand? Now we know at this point, Sandile catches it here. With what speed will it hit his hand when it comes down here? He started with 8. When he catches it, he'll catch it also with 8. But he started at 8 upwards. He'll catch it when this ball is falling downwards. Now I'm confused, ladies and gentlemen. I just told you all down is negative. Do I write minus 8? Yes or no? Is this question 4.1 a calculation or a describing question? You do not put negative signs in descriptions. I'm making it clear. 90% of you will write minus 9.8. 90% of you will write 8, forget the downwards. Some of you will not even write the unit when it was given in the data, man. That is how careless we are. Again, reason being, we have never done homework in our life. There's no other reason. If you are failing VPM, you never did a stitch of homework. We've got to take accountability, learners. We are ladies and gentlemen. We've got to be accountable now. Right? Using equation motion and not energy principles, calculate the maximum height reached above the ground. 4.3 is a nightmare. It's a description question in English that throws learners off the topic. If the window on the top of the floor is at a height of 2.5 meters above his hand, calculate the time taken from the moment the ball was thrown to pass the top of the window on its return to his hand. Now we need to understand what's going on there. And number 4, taking upward direction as positive, draw a sketch graph of position versus time for the entire ball's motion. Use Sandile's hand as reference. Right. Now, using an equation of motion, once again, calculate the maximum height reached by the ball. Now, this, again, if you look at the mark scheme, it's not difficult. It's only 4 marks. Now, when they say use an equation of motion, we got to pick from 4. And the problem is choosing the correct equation. What do we have, ladies and gentlemen? We have, it looks like I have to write here. Can you see this? Right, we have VI is plus 8. We have A minus 9.8. We have, at maximum height, VF is equal to 0. And I want the height achieved. So that will be delta Y. You can actually use delta X too. They're still marking it right. The Y and X simply mean the X value, X is when it's horizontal motion, Y is vertical. Right? You want delta Y. Now if you look at the information, ladies and gentlemen, for 4.2, right? I want 4.2. Right? If I look at 4.2, the information, all these have no time. There's no time. There's only one equation in the data sheet with no time. It is that one you don't like. VF squared is equal to VI squared plus 2A delta X, which is 0 squared is equal to H squared plus 2 times minus 9.8 times delta X, or Y you can prefer, and delta X becomes 3,27 meters. Now I just want to bring the question paper back here for a second. So what we've worked out is this bracket, 3.27 meters. Okay, ladies and gentlemen? Now, that's the height above the platform. Right? Above the platform. Because that's where Sandila is standing. They want the height above the... So, there's the ground here. If he's 3.27 up there, there's the balance here from the ground. Can you see that? So you got to add that 1.73 to 3.27. Okay? Right? So I'll show you the memo now. Right? 4.3 or 4.2 rather. Right? Look at the mark scheme. There is no alternate answer, ladies and gentlemen. That's what I'm warning you about. The data given now in the exam papers, if you looked at your vertical motion this term as well, there was no alternate equations for your answers. You had to pick the correct one. In this case, this thing had no time. You cannot use an equation with time. You get 0 for the whole question. So formula, left-hand side, right? Answer, no mark for answer. No mark for answer. Because the examiner asked from the ground. Adding that to give you a total of 5. Okay? Next question. Calculate using if the window on the top floor of the building is at a height of 2.5 from Sandile's hand, calculate the time taken for the ball from the moment it was thrown to pass the top of the window on his return. So what the examiner is telling you is this, ladies and gentlemen. You see that black curved path? I'm going over it now. The examiner wants information for that section of the journey. Only. So you threw it, it went in a parabolic path to the top of the window. They want the value there. The value of the velocity. Oh, sorry, the time it takes. They want this parabolic time. Now, how do we do this, ladies and gentlemen? Pay attention. There's some noises. Calm down there, please. Sandila started his journey there. He finished the journey there. This is what the examiner wants. The straight line. Oh. So I've got to go faster. Okay. So we want information on this. There is only, the most important thing is this one, people. Delta X is minus 2.5. Because the object, oh sorry, not minus 2.5, plus 2.5. The straight line from start to finish is upwards. start to finish. So delta x will be positive. And then you pick an equation of motion again to solve this thing. And there's only one. Right? You got to first find the V final at the end of that journey. You got to find V final there. V final, VI is plus 8 and A minus 9.8. And the delta X is there, 2.5. Right, there's it there. And you get V final. Then you take that V final, please note I put a minus sign. You take that V final and substitute it in this equation to find the time, and you get 1.21 seconds. So it was 5 marks, 2 steps. Now this is a tip, ladies and gentlemen. Whenever there are questions of this type, 5 marks, 4 marks, it will be a multi-step calculation. There'll be 2 or 3 steps. Don't forget it. 7 marks could be 3 steps. 9 marks could be 4 steps. Right? Again, this was equation specific. Okay? The time you could have used other equations as well. But this was important, this step here. And 4.4, the easiest graph to draw in the world is the graph that the path the object took. If you throw something up and down, the parabolic curve you see the object takes is the graph you will draw for the position time graph. The maximum height achieved, he started from his hand, I labeled it hand, it rose 3.27 meters and came back in a time. The final time the examiner didn't ask for it. So you can call it T final or just T. Okay? 4 marks, 4 ticks. Very generously I gave mark for labels here. Right? But we normally don't give marks for labels. Right? Starting from 0, 1 mark. Shape of the graph, 2nd mark. Highest point achieved with the coordinate and shape. You can't put a weird shape. I can't, for example, draw a shape like this and put 3.27 there. It's wrong. You can't draw a funny shape and then put a coordinate there and expect the marks. But sir, the coordinate is right, but the shape is wrong. So I can't mark one right, one wrong and give you 1. Both these correct to get the tick. So be careful of that. That shape must be correct to get that coordinate. Must be correct. Right? And I think we're on break now, sir. Am I right? Right? Right, minimized. Right, we'll have a short half an hour break and get back to you at 11 o'clock. Thank you. Yeah, the only thing is I'm slow. I'm very slow. Because see, the guys on that side don't have the questions.
come in.
All right, welcome back to continue with our journey on physical science. What we're going to do is this thing set up properly. Let's double check it, please. See, my pen is there, but they can't see it. I'm trying to fill the whole page here now. It's still sideways, eh? Okay.
Earlier on it was fine.
Yeah, because I moved it. Okay. I'll go closer there. Right, we're ready. We're good to go. All right, welcome back, learners. We are going to follow the program now and continue with the physical science paper 1 and look at a question. After vertical motion comes the energy principles and thereafter the Doppler effect. So we're looking at, I'll first do a question on the Doppler effect and get back to the energy principles shortly. Right, the question is here. Right, this question is not in anybody's booklets. We'll have to take it down the best way to record it, but I'll do this next. I just want to look at the question on the Doppler effect. Right, it's in our booklets, ladies and gentlemen, those of you who are in front of me. I'll just show you the page. It's question 6. Right, it's a graph about a car or a police car with a siren with 800 hertz. It's next to question 2 in your booklet. Right, I'm going to be looking at that. I'll just look at the original question because it's much larger for the online learners. Okay? Right, we're looking at question 6. Right? A man mounts a siren which produces a constant frequency of 800 hertz. Now, immediately when we see 800 hertz, constant frequency, this has to be F, the original Fs, right? The source frequency on the roof of his car. He drives at constant speed. We will always have constant velocity of the object if it's moving in terms of the Doppler effect, right? The acceleration of the constant acceleration effects we'll do in university next year, right? Up and down a straight road while a stationary listener observes this sound. Now, if you are moving on a straight road, if you are a stationary listener, let's call this velocity of listener 0. Stationary listener. If the car is moving forward and backwards, it means it can come towards you or away from you. And we know when you observe a frequency or the pitch with your ears, when the car approaches you, perceive a higher pitch. And when it moves away from you, FL is smaller than FS, and you perceive a lower pitch. Now that they haven't told us yet. All we know is the car can drive forwards and backwards and the listener is stationary. At a certain stage in the journey, the learner maintains the following pressure time graph. So this learner observed the frequency FL in terms of a graph. A very, very scientific learner got some scientific equipment and measured the frequency in terms of a graph. Again, we don't know whether that frequency he observed is bigger than the source frequency Fs or smaller. We know this is a graph of L. Whether it's greater than or less than Fs, we don't know. So we need to interpret this graph, this pressure time graph of a sound wave, to compare it to the hertz given originally as 800 hertz. Is this graph 2000 hertz? Is it 400 hertz? We don't know. And that will be the first question the examiner will ask you. The most important thing is labeling this graph FL and labeling the 800 FS. Otherwise, you're going to lose all the marks thereafter. And that's an interpretation kind of question. It is not a physics question where you lose the marks. You lost the marks because of poor analysis of question. Right? So, let's look at our graph. Firstly, it's got an exponent, 10 to the minus 4. Be wary of that. So if you're reading this value, it's not 7.5, it's actually 7.5 times 10 to the minus 4. That's 2.5 times 10 to the minus 4. This value where arrow is, what value will that be? If this middle sector is 2.5, what will that sector be? We are counting 0, 2.5, 5. Now is it 5 or 5 times 10 to the minus 4? 5 times 10 to the minus 4. What about this coordinate here at the end here, that one? 10 times 10 to the minus 4. Or 1 times 10 to the minus 3. You can type it in your calculator and you'll see it can give you that answer. Seconds. Now this is obviously time in seconds, and time is related to period of a wave. Grade 10, period, which is time, is the inverse of frequency. So if we want to find FL, grade 10 work, FL will be the inverse of the period of this wave. Grade 10. So you could not calculate the observed frequency if you didn't go back to grade 10. And unfortunately, that equation, ladies and gentlemen, is not in the metric data sheet. You got to remember this. I hope it is there this year. We made a suggestion to put the grade 10 equations for period and frequency in the data sheet. I hope it's there. Right? So number one, what is the period of the detected wave? So period, right, is simply, let me write it here. T is equal to, this is 6.1. T is equal to 1 over, T, we simply read it from the graph. Now let's go back here. Let's see how many marks is it? It's only 1. Which of these coordinates that I am dotting is the period? First, middle, or last? It's the last one. The period, by definition in grade 10, is the time taken for one cycle. So it's 10 times 10 to the minus 4 seconds. SEC is marked wrong. Sec, there's no such abbreviation. The abbreviation for second is S, not SEC. You write SEC, it's wrong. 6.2, calculate the frequency of the detected wave. Now that's 3 marks. So the frequency, many learners, if you look at the options in the data sheet, you've got the Doppler equation. FL equals V plus minus VL over V plus minus VS times F of S. Learners will start with that. They'll also start with the wave equation from grade 10. V is equal to F times lambda. Now you haven't got wavelength in this question. How can you solve with that equation? Not allowed. The only option is this option. There's it there in the circle. The observed frequency is the inverse of your period. So 6.2 FL is equal to the inverse of period, which is 1 over 10 times 10 to the minus 4. And I think that is 1,000 if I'm not mistaken. I don't know, where's my memo? I don't like looking at memos. Question 6. Yeah, it is 1,000 hertz. And now we can see FL is greater than FS because FS was 800. The observed frequency the learner picked up with his graph is actually 1,000 hertz. 800 is smaller than 1000. And now that we got FL and FS, we can now work out the grade 12 calculation, which only came in 6. So please be wary of this, learners. This happened in your trial exam. You have to use this equation, learners. V is equal to F lambda in the trial. Please do not underestimate the power of grade 10 waves and sound. I hope you did it. 6.3, state the definition, Doppler effect. The Doppler effect is the apparent change in frequency observed by a listener. You've got to write the word apparent change. You can't say it's the frequency. It's the change in frequency observed by a listener. When the sound waves are moving in relative to the listener. When the source of sound is moving relative to the listener, or the listener is moving relative to the source of sound. Or use the 3-line definition from the CAPS document. You have to write it like CAPS, no other answer. Calculate the speed of the moving car. Now we go back to our question. Our car had the siren. So that is V source. The listener was stationary. There's it there. You must write VL equals 0. So let's write down what information do we have from the comprehension. 6.4. FL, we already just worked out 1000. FS, 800. VL, 0. VS is VS, unknown. VS is VS. Ladies and gentlemen, you have it here in front of you on this booklet. I showed it to you earlier on, right? Find this one. And V sound in air. Now, did they give it to us? Let's go back. Here it is. Speed of sound in air is the slowest. It's the fastest in a solid, right? Second fastest in a liquid like water, 1,400 to 1,500 meters per second. V sound in water. And V sound in air is 330 to 340, right? Please check the medium in which sound travels in the exam, right? And those of you who forgot grade 10 work, sound does not travel in a vacuum. It's outer space, right? You need things like what I'm wearing now to talk to each other if you're an astronaut. Right, now that we've got our values and we know the car is approaching the listener because FL is bigger than FS. So we're going to add the top and subtract the bottom in our equation. First thing you do that, V plus minus VS or V plus minus VL. Now we know we're adding the top, we're minusing the bottom. Many learners have forgotten that FS is multiplied by this bracket and FL is initially in the start of the equation. Many of you are forgetting this term. I don't know why, it's in the data sheet. The rest is maths. Physics is now done. We substitute. FL is 1,000, V is 340, VS, V plus minus VL, sorry, not S there. VL, V plus minus VS there, that's right. VL is 0, V minus, this is 340, minus VS multiplied by 800. And you can type this in your calculator. If you have that white calculator, it's got a button called solve. You type all this in brackets in that white calculator, that sharp white calculator. Type it all in brackets. Where you've got this, you type in X and press solve. That thing will solve it immediately. And you get VS to be 68 meters per second. Right? Now, this man or woman is absolutely speeding. Remember, around 33 meters per second is the speed limit on a highway. This is on double that. This is over 200 kilometers an hour. Right? So this observer could have been a police with a speed trap. You, the learner, the cop, the learning policeman or woman. Right? this car is speeding. Okay? And that's the Doppler effect. This kind of calculation was level 3. Why level 3? It was based on that. Then this is based answer. So by getting these two right, you're going to get full marks. If you get these wrong, you can get full marks provided your mathematics in the physics is correct. If you redid this, you get 0. In other words, you took this answer and never used it again. You'll get naught thereafter. If you change anything here and didn't make the change here, you get nothing. 6.5 is level 3. English question. Now, you must get used to the questions, learners. Definition, theory, calculation, theory again. 6.5, theory. This is for the learner who wants 100%. You can't get 14 out of 14. While the car is stationary at rest, the frequency is changed to 900. It was 800 before. So frequency source has increased. Will the wavelength detected of the sound wave increase, decrease, or stay the same? It increase. Now, how do you explain this for 3 marks? How do we explain it for 3 marks? Right. There's your answer. Whenever there is a question in English, there's always a mathematical way of proving it. Can you see I've used maths here to prove it? From the equation V equals F lambda, if V is constant, the frequency observed is inversely proportional to lambda. If frequency increases to 900, lambda will do the inverse. Lambda will decrease in air if the car is stationary. Always answer what the examiner wanted. He didn't ask about the moving car, he asked about the stationary car. Understood? Now you can use this question or this answer, the first line in this answer, in the photoelectric effect. Isn't we use this equation also in the photoelectric effect? We can use the first line in the photoelectric effect. Remember that. It came out in your paper in the trial. You had to use you had to use this formula for 10.2. You couldn't use the photoelectric equation. You didn't start like this, you got 0, nothing. Right. And that's the Doppler. Our next question I want to tackle is this one, which is not in your books. Right? Our favorite friend, the work energy theorem. I am sure learners hate this question. Learners, do you all like this question? Right. The good news is, if you look at the papers that they are setting in all provinces now, the work energy theorem, the marks have decreased. Like in this case, the mark is only 12, I think, or 15. No more 19, 20, 22. So they're putting in that extra marks in question 8, 9, and 10, ladies and gentlemen. Please be wary of that. That extra marks they took from here is going into electricity, statics, and alternating current theory. Please remember that. Look at your trial exam, those marks were high there. Okay? We have a helicopter on the ground, lowering a crate with supplies of mass 50 kgs onto the ground. When the crate is 120 meters above the ground, it has a speed of 2 meters per second. The crate is lowered at acceleration. Now, if you lower something to the ground, are you speeding it or slowing it down to stop it? So this thing's got a negative A. Did they tell you that in the exam, the English here? Did they say negative constant acceleration? You must know that. I mean, if you're dropping something from a helicopter, you're not going to accelerate that to kill somebody. You're going to slow it down so it doesn't break when it hits the floor. Am I right? And you'll actually slow it down to stop. V final will be 0. Yes? Now, if you didn't understand all that, you mess up this question. The crate is lowered at constant negative acceleration onto the ground with a cable when it comes to rest. That will tell you from 2, If VI is plus 2 and VF is 0, you have to slow it down to stop it. Common sense. Make sure you do things like this in your exam paper. On the question paper, write like me. These are tricks that you're going to use. Mass is 50 kgs. Right? You know it's going to come out negative. You know it's a negative A. Right? It's A. Delta S, 20 meters it took to fall during this journey. So it's looking familiar to us in the data sheet. M's MVI squared. Rings a bell, isn't it? So we got to use kinetic energy or the difference in kinetic energy called the work energy theorem. Right? Air friction is not ignored. So now common sense. If I'm lowering something down, air friction is going to be, air friction will be upwards. Makes sense? Friction opposes the direction of the motion. Makes sense? Good. Now we start. Now all this writing that I have done, you guys must do it yourself in your strategy when you are answering on your script. Show the examiner your thinking. Because this writing in green pen here was not given to you. You extracted it. And it makes your life very easy when you are answering the question 5.1, 5.2, 5.3. 5.1 theory. What is a non-conservative force? Work done by this force is part. Now, is it either dependent or independent? Non-conservative. Dependent or independent? Dependent. If it was non-conservative force, a conservative force, I'll just block that non off, you write the same thing, but say part independent and get 2 out of 2. Got it? Good. Identify the 2 non-conservative forces acting on the crate during its downward motion. Now, if I draw the free body diagram, Earth does it naturally with weights, right? Air friction is upwards because the object is moving downwards. There is another force here in this line. What is this line here? What is this thing? Tension T upwards. So I'm going to make my dot a little fatter and write tension, not T. Tension T. Now they want you to identify the 2 non-conservative. Which are the 2 non-conservative? Right, you block weight. It's air friction and tension. So you write it in English. Will you draw a free body diagram for this? The teacher says, identify. Does that mean draw a diagram? No, you write it in English. You'll say air friction or friction simply with tension. You cannot use abbreviations for that. Number 3, draw a free body diagram showing all forces acting on the crate for 3 marks. There, he's telling you, draw 3 forces. And there it is. This is 5.3. Right? You see how important your problem-solving strategy is. Right? Is that understood, learners? And now we can work out the work energy theorem, using the work energy theorem. The work done can be, the equation for the network is taken from your diagram. W net, let me write it here, is the work done by W, the weight, plus the work done by friction, against friction, plus the work done by tension. The moment you got your free body diagram correct, you can write your own equation for network. But the problem is, you see these W's are not newtons, they're in joules. And W is factorized as F cos theta delta x. 1, 2, 3 terms. So these 3 W's have 9 values. That's what you learners must understand. When you factorize these, you're going to write this 3 times. 3 for this, 3 for this, and 3 for that. And W net is written as delta K. Or, let me write it here. W net is half mvf squared minus half mvi squared. And many learners forget in the data sheet, W net is also equal to F net cos theta delta x. So where you've got W net, you can replace it with this entire thing that I'm underlining. Or replace it with this. Now that is why learners find it challenging in the exam. We don't know which W net equation to use. And now I'm telling you, these are the 3 for every example. Right? Every example you're going to have 3. Your own from your free body diagram or the 2 from the data sheet. Kf minus Ki does not help us in the data sheet. You go to factorize that thing and open it up. And then you look at, learners, you look at your information given here. Now which W net equation will fit for us? You agree it will be this option here? The first option I've underlined? Because I got MVF and MVI. Can you see that? That's how you make your selection, learners. There's no other way. Right? Is that understood by all? Good. 5.4, state the work energy theorem in words. The work energy theorem states that the net work, I mean some of us are so lazy we don't write the word net here. We write W. You fail if you leave out the word net. We mark it wrong. You lose the last 6 marks if you haven't got the word net. Read the rules of marking. The equation is wrong, stop marking, it's there. Right? The net work done on an object, the net work done object is equal to, not equals, is equal to the change in the kinetic energy. I'll just put EK in the end here, I'm going to write it in English. Is equal to the change in the kinetic energy. Every word must be there. Again, this came out, every year it comes out. People leave out the word change or they leave out the word net. It's wrong, you got 0. Final exams, we're not so lenient. Right, 5.5, use the work energy theorem to calculate the acceleration of the grate as it's lowered to the ground. Now, this question can be solved with this. Right? Use your free body diagram. Right? I'll just show you quickly. Friction, tension, weight. Right? F net. This crate is being lowered. In other words, decelerating. Is F net upwards or downwards, people? If it's slowing down, where's your net force? The net force is the sum of these two. In which direction would that net force be the sum of all those arrows? Up or down if you're slowing down? Up. F net is up. Now you can use this equation. F net equals MA, which is T plus F minus W or W minus whatever you use, and get full marks and get A. You will get 0. You can't do this method, not allowed. Because the examiner made it clear. He said use energy principles. What you must use? Specifically which principle? The work energy theorem. So your answer in your equation must start with the words W net. If you got MA in the equation, you start like that, you'll fail. You'll get the answer of A, you get 0 to 6. So be careful, people. When they say energy theory principles, there's two principles. W net is equal to this. 1, 2, 3. Oh, WNC. You all heard of this equation before. It's in the data sheet. Is equal to delta U plus delta K, which is meaning you need to factorize this as well. mg into hf minus hi, right? Plus half mvf squared minus half mvi squared. I don't like factorizing this because children mess it up. So you can use 4 methods to solve this thing. In this case, the examiner says, sorry, WNC method is out. This is called the law of conservation of energy. This is the law. Not U plus K equals U plus K. EP plus EK equals EP plus EK is not allowed. You must use this one. Right? My safest option for you learners, all of you, you pick from these 3. You pick from your 3. 1, 2, 3. Even in the exam, the examiner will say, use energy principles. You got 4 options. Pick the one that matches your information. Yeah. Now, the examiner asks for acceleration. I believe, is it acceleration in F net? Yes or no? Is it acceleration F net? F net produces an A? Yes. And you agree also, I've got MVF and VI here. So, I got to amalgamate these 2 equations into one. Half mvf squared, let me show you on the screen properly. Half mvf squared minus half mvi squared is equal to f net cos theta delta x. And that is how I will solve this thing and get my 6 marks. Understood, learners? Now let's do it. 6 or 5.5. W net is equal to delta K. Now you simplify that thing. W net is F net cos delta X is equal to half mvf squared minus half mvi squared. Right? But I can simplify this further because the examiner asked you for A. Isn't F net equals MA? Yes or no? Cos delta X is equal to half mvf squared minus half mvi squared. Now I'm going to show you a funny thing that you're going to get shocked with. How many marks for all this? Nothing. There's no substitution done yet. You only get the formula mark. And that's where the tick is. When shooting all the 9 values. You don't get this tick if there's no substitutions. MA, I think the mass was 50 if I'm not mistaken. A cos, I'm going to leave it blank for now, I'm coming to that just now. Delta X was 20 meters, half, mass is 50, V final is 0 squared, it stopped. Half of 50, V initial was 2 ms down, squared. Many learners forget to square. It is a sin to copy incorrectly from the data sheet. You'll forget that thing because you are rushing. Please calm down. Now this cos is level 3. There's only 2 values for cos theta, 0 or 180. 90 you don't even write because you leave that vector out. If you want to, you can put that thing too. Cos 90 is 0, then it drops off. We come back here, learners. Our object is rising or falling? Rising or falling? The object is falling down. But in which direction is F net when you're slowing? Up. Are these same directions or opposing directions? So do we say cos of 0 or cos of 180? Yes, delta x is downwards, but F net is upwards, cos of 180. Now, what if you put cos of 0 there? Will you get 6 out of 6? You will get the answer right, you know that, huh? You get 3 out of 6. You put cos 0. Because you didn't understand that the object was slowing down. If that he fell at the speed, you murdered someone. All right, and you get A to B. I don't know what the answer is here. I think it's 0, something. 0,1 mm. Upwards. Did they say A? Yeah, you have to write the direction, please, ladies and gentlemen. All right? If you put cos of 180 or cos of 0, you'll get negative answer. And your answer will be wrong. You don't get negative vectors in the work energy theorem. Remember that. There's no negative vectors. You can never put a negative there. Never. Never, ever. The cos takes care of the direction. Agreed? Don't put a minus sign here, ever, for forces. Right, and that's the work energy theorem, ladies and gentlemen. I hope you understood that thing. Right? Learn to amalgamate equations. Marry them together by looking at the information given. He asked for A, F net got MA there. VF and VI were given, then use that part of the work energy theorem in the data sheet. Right? It's not difficult if you got a strategy. And if they fail, don't forget you got your 9 options here. 3 terms, 3 terms, 3 terms. One of them will always work. They will always work. Right. But let's look for another question for our ladies and gentlemen. Electricity, okay. Right, I want to look at this question, current electricity. Right, I'll just show it to you, you audience. It's question 9, it's the 3rd or 4th page from the front. Question 9, okay. And I'll get the original document for the online learners. Question 9. Right, this is it. Right, you can find it in your document there, ladies and gentlemen. Question 9 for the online learners. I'm picking a question on current electricity, right, with R internal. Now, if you look at this question, it's a very simple, straightforward diagram. Before I do anything, right, I like to use 3 different color pens, right? Maybe black, green, and red or orange, to look for my currents in series and parallel. Because we must understand that we are never going to get grade 9 work in metric. We are going to get branch currents with voltages in those branches not given. They're not going to give it to you, because we are senior learners. So they're going to make this question level 2 exam, not level 2 and level 1. Right? So your currents in series and parallel first. And then know, oh, this color, if this color is there, that is verb. I'll show you what I mean when I use the pens. An 8 ohm resistor, a light bulb and a rheostat, a connected volt battery, internal resistance of 0.4. The power of the light bulb is 8.1 watts. Now again, the only light bulb is this, right? This examiner was very friendly, he wrote it for you, the power, right? Please note, watts is power. The rheostat is changed until the ammeter reading shows 1.5 when the switch is closed. So I'm closing the switch, and the ammeter reading is 1.5 amps. Now I'm going to use this green pen. Current flows from the positive pole to around the circuit. When it comes here, it's going to branch into 2 different currents. A reddish one goes through there and meets. It waits there at that T junction because another current is coming to meet it in black. Right? And the green split up into red plus black. So red and black meet here. What color must I use now? Green. And now you can see, hey, the green current goes to the ammeter. So this is I total. Or the series current. Or the main current. Now you know you give an I total. So you can use the EMF equation. EMF is equal to I into R plus R. I total is given. You got to worry about R total and V total after that. So I total, there's it. And don't forget that same current goes to the battery. I total also flows through the light bulb. And if you go to your data sheet, P is equal to I squared R is in the data sheet. So the power is 8.1 watts. I squared is 1.5 squared. I can find the resistance of that light. Not using Ohm's law, using a power equation. Now this is new to you. Normally you're using I, V and R. There are also equations for work, energy and power in the data sheet. They don't have to give you the V and I all the time. They can give you the power. You go and calculate the R using another method. Can you see that, ladies and gentlemen? So, and that is the first question. Calculate the resistance of the bulb. So 9.1, right? P is equal to I squared R. So R will be 8.1 divided by 1.5 squared. Right? And the answer should be, right? Look at my memo I wrote. Question 9, this is 3.6 ohms. And that's 3 marks, easy, straightforward marks for learners. Right? 9.2 is calculate the resistance of the rheostat. I'll call it R1 because the other one I called it R. I don't know that resistance when it gives this current reading. A rheostat varies I total. You can increase this or decrease it. It's got a slider or a switch on it that can increase or decrease resistance, and then it changes I total because R total changes. When you move this resistor, your resistor is like your dimming switch in your house. When you dim and brighten the lights, those are variable resistors. When you dim the lights, there's less current, I total decreased. When you make it brighter, I total increased. But R total did the opposite. So, calculate the resistance of the rheostat when the ammeter is 1.5 amperes. Now that is 6 marks. Why? Because we want the resistance. If I turn the page, we turn it this way for learners. Is it we call this R top and the resistance at the bottom? Agreed? So R top is missing. R bottom is 8 ohms. We need to find the top resistance in parallel. Can you see the current split here? So these are parallel to each other. So we need to find 1 over R1 plus 1 over R2 equals 1 over RP. But we don't even have RP. So how do we solve this, learners? The only resistance we have is from 9.1, 3.6 ohms. And we got baby R to be 0.4 ohms there. How do we solve it? When in doubt, use your data sheet as your best friend. Let's see how the data sheet can help us. Right? How the data sheet helps us. 9.2. EMF is equal to I into R plus R. The EMF was given as 8.4 volts. The I was 1.5. The big R is unknown. Remember, this is external resistance. But the small r is 0.4. I think I can find that. I can solve for R external, right, to be 5.2 ohms. If you put this in the calculator to solve it, you get R external to be 5.2. But R external can be broken up into every resistor in series added to the parallel combination. External means resistors outside the battery. So you don't put baby R there. If you put baby R, what does this word change to? Anybody knows? What does the word external change to if you put baby R? R? Total. So don't put that thing. So R external is 5.2. R series is, there it is here, 3.6. We worked it out earlier on. Plus RP. So RP is equal to 5.2 minus 3.6, which is 1.6 ohms. But you still haven't found the R top, isn't it? So now you say 1 over RP is 1 over R, I'll call it X, right? Plus 1 over R2, right? Subscripts are not penalized in the exam. But do not leave out that P, because it's in the data sheet. You put 1 over R, it's marked wrong, because the examiner says the child was careless and didn't read properly. Be wary of all this, please. So 1 over 1.6 is equal to 1 over R, X if you want. You can leave the X out, it's up to you. Plus, and the other parallel branch was 8. You type this in your calculator and you get Rx to be 2 ohms. And you should get 6 marks for this. Now it was quite a lengthy calculation. It started with equation 1, step 1, then step 2, and finally you did step 3. So it's a multi-step answer. Multi-step answer for 6 marks. Now it's not 2 marks each, unfortunately. The most marks come in part 3. Yeah. Right? So please, there are other ways of doing this. There are many other ways of solving it. I just took one route, okay? Now once you've got these values, the question becomes easier. It becomes easier. Suppose you got them wrong. Take your wrong answer and put it in right equations, you'll get full marks. It's called carry-over error. Have you all heard of that before? The carry-over of your incorrect answer to the next question. You put it in the correct equations, you get full marks. Right? Next question. 9 point, let's come back to our question. 9.3, calculate V1 using your conditions from previous question. 9.2. So V1, now let's look at where V1 is. There's the voltmeter connected across the battery. Now, in that when you buy a battery 4 volts and you measure its voltage in a shop, it'll give you 8.4 volts. You are correct. But when you connect it and there's a current flowing, that current multiplies with baby R. What it does, it multiplies with baby R and becomes lost volts. Do you understand that? So that battery will never read 8.4 because baby R will multiply and steal that energy away in volts. To calculate V1, very know what 8.4 is, V total. I can find baby R, which is next multiplied by the total current to get the lost volts. So all I do is I say, any ways of solving this 9 point, I will use my way. Right? 9.3, V lost is equal to I times baby R, which is a 1.5 times 0.4. And what that is, well, I don't know what it is, whatever it is. Somebody just give me the answer. I don't have it here. I did a different method. I'm doing another method now here. 0.6 volts. So, therefore, V external is equal to V total minus V lost. That's your own equation. You understand it. So the total volt was 8.4, V lost is 0.6, and you get 7.8 volts, I think. Is that correct? 7.8? Yeah, correct, 7.8. So you bought a battery of 8.4. When you connect it to a 1.5 amp current in a circuit, it drops to 7.8. And this is what many of us don't understand. I total influences how much you lose. The greater this I total is, the greater you lose. And the less V output is. Now if you look at our question, we lost very little volts, only 0.6. So our output is bigger. The less you lose, the more you get out. Because I total, although I total was large, this is an excellent battery. Baby R is in the decimals. It's not even 1 ohm, it's 0.4 ohms. So when one of these are small, that's small. If that's small, then this is small. If current total is small, then that's small. And V external is large. Don't forget it, please. Right? Can you see this is more of thinking than using data sheets all the time? Can you see that? So trust your gut, people. 9.4. Right. 9.4 is level 3. The rheostat is adjusted dramatically to increase. The resistance increases. Now we worked it out just now to be 2 ohms. Now dramatic increase, let's make it 1,000 ohms. Dramatically increased. That's what the examiner says. If you make this resistor very high in ohms, what happens to the following? Total resistance, the EMF of the battery, and V1, which is V external. To get full marks, you must get all these right. Now, you haven't seen one like this before. And this is where, there's the level 4 here, ladies and gentlemen. This is the level 4 question. It's only 1 mark. The answer is increase. The EMF of the battery. You change this current or this resistor here. Does that change the 8.4? It can never change. You can only change EMF when you replace the battery. So, second answer remains the same. The reading on V external. Now this is directly related to R total. So let's start. I told you this earlier on. If R total increases, I total, because R total increased here, number 1. I total must decrease. Therefore, IR, which is called loss volts, will decrease. Whatever happens to I total happens to loss volts. Remember that. The opposite happens to R total. Never forget that. This is compulsory for all. Whenever R total changes, the inverse happens to I total. You don't get 1 mark each here. This entire sentence is only 1 mark in the question. See, learners. The entire sentence. What happened to my question now? Oh, sorry. It disappeared. Okay. Right? The entire question is only 1. So to get that 1 is a lot of thinking. Level 4 or level 3. So let me show you the answer again. Right? If R total increases, I total decreases, loss volts decreases, and from V tot, which is EMF, is equal to Vx plus V lost. If this drops, that must increase because this can never change. This is constant. Remember, it's 8.4. Right? Let's give you an example. If this is 0.4, that has to be 8. Because 8 plus 0.4 8 plus 0,4 must give you 8.4. If V loss decreases to 0,2, isn't this must become 8.2? So when that goes down, this must go up. When this goes up, that must go. Got it? And it's all dependent on this sentence here. So generally this question is 4 marks. In this paper, the examiner was greedy, made it 1. Right? Now obviously, if this appears at the end of the year, they're going to ask you to give a reason. There's the reason. Please do not write arrows for the word increase and downward arrow for decrease. Write in proper English. Not INC and DEC. Proper English. Okay? I hope you're clear on that, people. Right? Let's move on. You'll need time to take this down. Are we all good? Right? I just want to see. Online. Question there. Okay. Okay. Right. I like this kind of question. It makes it easy for the learners because once you solve for R total, the answer, the entire question becomes simplified. Once you get R total, you see, everything, once you get that R and you find R total, therefore, you got all 3 R's in the equation. This equation is misleading to learners. This R is actually RP plus RS. Don't forget that. Many learners think there's 1 number there. There's 2 numbers. Sometimes this is 0. You got no parallel connections. Sometimes that's 0. You know, got no series users. Watch for that. Okay. Right. That's it there. We go to another question in our booklet. I'll put it up on the screen shortly. Right. I'm looking for something with alternating current theory. Right. Alternating current theory, AC theory or electric machines. Okay. Electric machines. All right, I found one. This one. Question 10. Right. Right, it's familiar to us. We have seen one like this in past papers of the previous years. Right, let's set it up. Right, question 10. The diagram below represents an electric machine P and a split ring commutator. Notice they didn't tell us whether it's a motor or generator. We don't know. We don't know if it's a motor or generator. But we can see from the picture that this is a load or user of energy. It's a user, it's not a battery. So this machine converts mechanical energy into electric to make that light shine. By turning this rotational coil here, there's a handle here to turn the coil up and down. And when you rotate that split ring, that current should switch on that light bulb. So this is definitely a generator. But it's got one split ring. Noisy there, please. Calm down. It's a DC generator. Once you identify it, then we're getting marks. Identify the type of electric machine and the energy conversion. So you say DC generator and the electric conversion, and the conversion is mechanical energy into electrical energy. Please do not abbreviate like me, write in full English, okay? I'm rushing for time. Understood? Now what's the mark scheme? It was 3. Identify the type of machine. Don't just put DC generator, you lose 2 marks. The examiner was clear. Identify the machine and write down the energy conversion. There were 2 parts to it. They're doing this in the Doppler questions as well. Be wary of the English. That's why the 10-minute reading time, you must be focused. You didn't focus in a trial? Don't worry about the trials or prep exams. Focus now. 10.2, explain the function of component P. Now there's 2 marks here. Component P is the ring. Now the split ring has 2 functions. You can see it's touching this block. So it makes contact with the carbon brush. Contact with the carbon brush, 1 mark. Ensure smooth rotation of the coil, 2nd mark. Right? Ensure smooth rotation of the coil, 2nd mark. Right? Sorry, my writing's a bit untidy. Makes contact with the carbon brushes to ensure smooth rotation of the coil, or keeps the current unidirectional, one direction. Unidirectional. Right? 10.2. Makes contact with carbon brushes, unidirectional current. 10.3. The split ring is replaced by 2 slip rings. Right? Or they didn't tell you 2, I'm telling you it's 2. Which of the following VT graphs corresponds to that change? Now this is a graph with voltage in the positive and negative axis. However, this is a graph with voltage only in the positive axis. So, which is the graph for our diagram? This is for DC. So this is for AC, and AC has 2 slip rings. SLIP. So 10.3, graph A is for AC, when you've got slip rings. The examiners showed you slip rings, so it's graph A. This is graph A. Right? I think that only is 1 mark. And underneath they said, explain your answer. Now the explanation is straightforward. Right? You'll say the 2 slip rings allow current to alternate. You get alternating current. Because you see 2 slip rings, which corresponds to the graph. You must tell the examiner. Corresponds to the graph as positive and negative voltages. You must tell him that that alternating current is the sine wave of the graph. Positive and negative voltages. Right? This actually should be minus 12 volts there. Right? That 12 volt, is that VRMS or Vmax in graph A here? That 12 volt, is that Vmax or VRMS? Very important to understand that. It's the maximum peak voltage. Right? The RMS voltage is actually somewhere there in dotted line. RMS is always less. Right? All right, 10.4. Let's get to 10.4. The light bulb shown in the circuit dissipates 6 watts of power. An identical light bulb, the N is missing here, an identical light bulb is connected parallel to it. Calculate the RMS current in the circuit under new conditions. Calculate the RMS current under new conditions in the circuit. So what they've done is, they've taken this light bulb and connected another identical one to it in parallel, and they want you to calculate the RMS current by giving the power in one bulb. Right? Now, so you write down your information. What's given? 10.4. What's given? We got the power is 6 watts. IRMS is what I need to calculate. IRMS. What else we given about the light bulb? You are given V max. Come back here. There's our V max. Right? Our V max is 12 volts. So we in trouble. We got RMS. RMS must rhyme with RMS. They must match. We got problems here. We got V max is 12 volts. Can I convert this into RMS? The answer is definitely yes. So an equation relating all three is P is equal to I times V. P is equal to, watch out learners, average power. Do not leave that word average out. I RMS times V RMS. Now I know we haven't got V RMS. We got V max. But I know V RMS is V max all over root 2. So where I've got the word V RMS, I can write this circle. I can write this here in my box. Wherever I got the word V RMS, I'm going to take it and put it here. And it's going to make my life easy. So P, 6I is missing. V RMS is V max all over root 2. 6 is equal to I RMS. V max is 12 over root 2. And we solve. Learners, we need to pay attention. And that is your I RMS. Incorrect. This is for one bulb. In the total circuit, isn't the current is identical? So you say I total, because the current branches in parallel, is 0.707 times 2, and you get 1.41. So if you stopped here, you get 3 out of 5. If you carried on, right, you'll get 2 more marks. The current is identical in parallel. Remember he said it's a parallel circuit. So you double the current. Right. Another question. Now this question, ladies and gentlemen, you have it with you. This question, you have it with you. Question 11. Right, this question is level 4. Why is this not coming up? Right, question 10.5. Right. Right, I haven't seen a question like this in about 10 years. Right? I haven't seen one like this in a long, long time. What they've done here is, in a nutshell, they have taken 2 sections of the syllabus and joined it. Alternating current theory with power and the work energy theorem all in one. Now that is a nightmare to solve. You agree? Work energy theorem, power, efficiency of power, and alternating current theory in one question. So let's have a look at what's going on here. Right? The diagram represents a motor connected to an EMF of 6 volts. It lifts a load of 3 newtons through a height of 0.8 meters in 2 seconds. So we've got F applied to be 3 newtons. We've got delta of height, delta to be 0.8 meters. We've got time to be 2 seconds. Determine the ammeter current. Right? Determine the ammeter reading. What's the time now? Okay. Okay, thanks. So, determine the ammeter reading the circuit. If 80% of electric energy in a motor is converted to lifting the load at a constant speed of 0.8 meters. Now, this is the efficiency of the motor, right? It is 80% efficient. Now, you must have done this equation in school. Efficiency is equal to actual power over theoretic times 100. Not 1,000, 100. So, we are given this part here. It's 80% efficient. Now, 80% is 80 out of 100 or 0,8. So I know the fraction is 0,8. How do we solve this level 4 question? We need to find current in this electric motor. Now, the current in this motor is supplied at 100% current. But the motor is only doing 80% work due to friction in the motor. The parts are moving in this friction. Heat is being lost. Do you understand? That ammeter, there's no heat loss in there. That resistor wire has no resistance. So it's 100%. So there's a lot of twists and tails in this question. But let's start with what we know. We got height, we got applied force, and we got time. I can calculate the power. The power of this entire motor. Right? 10.5. Right? I can calculate the power. Power is equal to the work done divided by time. It's in the data sheet. But the work done is equal to F cos theta delta X over delta T. This is also in the data sheet. Work can be factorized into that. And the force applied was 3. Now if I draw the free body diagram for this, the motor is lifting that thing with a cable. So you got tension, which is the F applied. And it's rising. So both these are in the same direction, cos of 0. And it displaced how many meters? 0,8. Right? In a time of 2 seconds. And you'll get your power of the motor to be 1.2 watts. So this is a motor of 1.2 watts. Remember, that's 80% efficient. Your ammeter reading is got no heat loss. So it's 100%. If 80% is 1. What will 100%? What will 100% be? Cross multiply and solve it. 100% will be 1.5 watts. Or you simply take, say, 100% power is equal to actual divided by 80% is 0,8. The actual power is 1.2 divided by 0,8 and you'll get 1.5 watts. Okay? Up to you how you do it. Cross multiply method or this way, I don't care. Now that you've got that, you say P. Right? You say power is equal to I times V, and the power is 1.5, I is I, and the voltage was given to be 6. So you get I to be 0,25 amperes. Right? So it is quite a lengthy question. Right? I is 0,25. So it's 2 marks per step here. Now let's go back to the original step. I'll give you time to take it down. The most important, at least get this marks. Calculate the power used to lift. Right? Now you know that power is 80%. 1.2 is 0,8. X will be 1. 100%, 100 over 100 is 1. And cross multiply and solve for X, you get 1.5. Then you take that 1.5 and you put it in your power in terms of current. And there's only one equation with power and current and voltage. P is equal to IV and you get quarter. Okay? I hope this doesn't come out in the exam. If it does, there's your strategy. Let's go back to it. Step 1, use the definition of power. Step 2, convert your 80% efficiency to 100% efficiency. because all circuits work on 100%. Step 3, select the appropriate current equation linked to power and voltage in the data sheet. And this is the only one. Right? Now, if, for example, you did not write this, you forgot this 1.5, you took 1.2 and you substituted it here. By mistake, you put 1. You forgot to work out the 100% power. You'll get 4 out of 6. You'll only lose 2 marks. It's not incompletely wrong. You just missed 1 step. Make sense? Right? I hope this comes out so all 250 of you get it right. And those online, are we praying for that? Right? And we'll do another question now. I think it's on page 1 before our break. Right? The photoelectric effect. It's the first page of your booklet, ladies and gentlemen. It's this one here. Right? The booklet. The online learners. Okay, sorry, it's not the first page. I'll find it for you shortly. Right, here we go. Right, online learners, the learners in front of me, the audience, you have it in front of you as the first page. Right? This is a far simpler question than the one that we received in our trial. Right? Just let me explain this a little bit. Right? These are called photodiodes. Right? They have a cathode. Your cathode is the metal plate. Now the photoelectric effect is an effect where you kick out electrons from a metal due to the action of light. Now, that was the definition that was asked. Many of you didn't say light of a suitable frequency must shine on a metal to release the electron. You can't just put any light there. Your light must beat the work function of the metal. So light of a suitable frequency above threshold frequency to release the electron produces the photoelectric effect. So many of you left out that sentence, we left out the marks. Right? So we've got an incident ray of light, or rays of light shining on the metal. The incident light has an energy, it should be photon energy. This is bad English. Because whenever you use the equation from the data sheet, that E is equal to HF. E is equal to HF, or E is equal to HC all over lambda. They gave you the wavelength of the incoming light. Those equations are used for 1 photon. Many learners don't realize that. 1 photon will kick out 1 electron. See, 1 photon came in, 1 electron came out. So you've got 20,000 photons, 20,000 electrons will be released. 2 billion photons, 2 billion electrons. So it's very important you understand that this is the energy of a single photon, a quantum of light. The cathode has a threshold frequency. The threshold frequency is related to W0, HF0. Threshold frequency is not an energy. That there is hertz. It fits there. It does not fit there. W is in joules. You cannot take something in hertz and substitute it in joules. That define the word threshold frequency. The minimum frequency needed to release an electron from the surface of a metal. Minimum frequency needed to release an electron. Surface of a metal. Minimum frequency needed to release an electron is crucial in the definition. From the surface of a metal, or from the metal surface, easier. Right? The incident light, this is something new, releases 2 billion electrons per second from the cathode. 2.01 billion. We want to calculate the ammeter reading. Now the ammeter reading is always given by I is equal to charge divided by time. That's from grade 9 syllabus. Whenever you calculate current, you take it from the definition of current. The rate of flow of charge. There's the definition. Right? So how do we get our answer from here? How do we get it? We want I missing. Q is also missing. Time we got 1 second. That's good. So we've got problems in our equation. No Q and no I. We need to find Q. There's this here. Those are 2 billion electrons. Electrons have a charge of 1.6 times 10 to the minus 19 coulombs each. Agreed, learners? Isn't that from the data sheet? So if I got 2 billion electrons, if one electron got this charge, what would be the charge of 2 billion electrons? This divided by this, or both those numbers multiplied? Divide or multiply? Multiply. So you say, step 1, I'll write it here if you prefer. Q is equal to N times QE from the data sheet, which is 2.01 billion multiplied by negative 1.6 times 10 to the minus 19. You must ignore this sign because we're finding current, right? Kind of negative current. And you get your answer here. Anybody knows what the answer is? I don't have it with me. Multiply this out, just call it out for me, somebody. And step 2, then you say I is equal to Q divided by T, delta T, which is whatever the answer is, divided by 1 and get your answer. What's his answer there, people? Anybody knows? Just do it in your calculator and round it up and give it to me. 2.01. This times this can't be. 3, yeah, it's 3 comma something. 3 comma 2. See, 3.16 times 10, 1, 3. Two, 1, 6, okay. 3.21, 3.22 times 10, 10. So you take that answer and put it here, divide it by 1 and get 3.22 times 10 to the minus 10 amperes. And which is correct? You get a very small current. So please remember this step. It could be asked at the end of the year. When they give you total number of electrons, multiply it by the charge to get the total charge of the electrons, and charge divided by time gives current. Right? The next question, the brightness of the incident light is now decreased. What effect will this change have on the current in 10.2? Now, if brightness decreases, you get less electrons per second striking the metal. And if you get less electrons per second striking the metal, you get less charge per unit time. So current will decrease. Current will decrease. Reason being, as I said, less photoelectrons in dimmer light, less photoelectrons released with dimmer light, therefore less charge, and if there's less charge per unit time, there's less current. Right, I think we can stop after I do this last calculation, which is not difficult. Calculate maximum K. So EK max or K max, both are accepted in the data sheet. So we go to our paper. Right? Right, our data sheet 10.4. E is equal to W0 plus K max. And now we factorize E. Oh, they gave it to us, 2.12 times 10 to the minus 18. Right? W0 is HF0 plus K max. Please do not forget the word maximum. I did not factorize this into half mv squared because the examiner didn't ask for the speed of the electron. If he asked for the speed, then you do this. He didn't ask, don't do it. Leave this thing as K max. He answered the question. He didn't ask for the velocity. So now we substitute. The physics is over, the rest is maths. H is Planck's constant. Now what is Planck's constant? 6.63. Is this Planck? Times 10 to the negative 34. Again, P plus 34. Yeah. You now a little tip, ladies and gentlemen. Whenever you're finding, remember all energies in joules. When you calculate that energy, will be either 10 to the minus 8, minus 19 or minus. If you get an answer for K max to be to the 24 joules, that's positive 24 compared to minus 18. You will know. If you worked out and got K max, you will know you got it wrong and got 0 out of 6. Because you can't values here. You can't, you're insane. Your examiners, you as a person who does homework, knows this answer will be minus 18, minus 19 or minus 20 of them. If you're getting positive values, you failed, people. Please have that. That is F0, they gave it to us as 2.21 times 10 to the power positive 18 plus K max. Right, you put this in your calculator, that minus all this will give you K max. Right? Which is whatever the answer is, I don't know. It should be the same exponent, minus 18 or minus 19 joules. Right? Work it out and you can call it out and that's your answer. Right, a small announcement for all of us, ladies and gentlemen, it's now 12:30. For our lunch break, a few things to worry about. Right, our lunch is at 12:30. No food will be allowed indoors. That means where you are seated now, for obvious reasons. I mean, we've got a limited staff here to help us clean up and so on, right? And please use the bins provided after eating. We do not want to have a scenario where we have ants and other pests troubling you tomorrow morning because we left food unattended. Because we're coming here tomorrow again to complete the second session. Am I right? So let's respect our place because we're coming back here again. Thank you. And thank you to you online learners.
And that was Miss Denikesh there doing the physics with our grade 12 students. If you're just joining us now, it is the Awqaf SA grade 12 physics exam preparation workshop, which is taking place today at Falaah College in KZN, and it will continue also tomorrow, where the main focus tomorrow will be on chemistry. So we do ask you to let all those who don't have information with regards to this, do tell them that we do have this workshop going on at Falaah College. We will be back at least by 1 o'clock to talk to some few other students. And you must remember as well that in January, we do have those workshops, competitions rather, that will be running. So you must make sure that you are part of those competitions. But at the moment, let's take a short breather. We'll be back at 1 o'clock with interviews for some of the students who are on the ground.
In the year 2000, Awqaf South Africa was pioneered as an institute of Awqaf and the empowerment of communities. South Africa faces a diverse set of challenges with a high unemployment rate and a stark divide between rich and poor, where electricity, hospital care and water shortages plague communities and where lack of education hinders progress. Awqaf South Africa is a catalyst for change. As a charitable endowment receiving organization, Awqaf invests endowment funds wisely and ensures that only the income generated from investments is used to fund a variety of community development projects. We are excelling in all that we do with the highest standards of ethics, integrity, and sincerity of purpose. From masjid development, imam empowerment to sports development, orphan support, food security, and surgery support, Awqaf South Africa is paving the way by investing in the future of communities and uplifting generations to come. Awqaf South Africa, creating a legacy of hope and
Hello there, my name is Sororisa Makaila. I am in my first year of my undergraduate studies in actuarial science at the University of Cape Town. And as a result of hard work, dedication, support from friends, family, and teachers, and Okaf's commitment to ensuring quality education for South Africans, I was able to obtain 100% in my matric examination for mathematics in 2022. So this was a culmination of very hard work that has been put in by myself and my teachers from earlier grades, more especially grade 11. I mean, this is a crucial part of your schooling career because universities offer provisional and conditional acceptances based on grade 11 results. And it's very heartbreaking to be willing to work hard towards your dreams in matric and not having anything to show for that with your grade 11 results. So it's very crucial that you work hard. And Okaf SA has been greatly instrumental in me reaching my goals in matric. I believe that you can derive great value in attending the Okaf SA mathematics workshops. I have gotten a lot of help from them and I have a lot to show for it. So please just check that out and keep on working on your dreams and ensuring that you have a bright future for yourself. Lastly, I would like to thank Okaf SA for their commitment in essentially building a better South Africa, because we know that in future careers that will be in great demand are those that involve science and mathematics, and by attending these workshops you'll be able to ensure that you participate in the future economy by working in these industries. So thank you very much to Okaf SA and good luck on your examinations.
When we take care of each other, wonderful things happen. Children thrive, the elderly rejoice, and communities celebrate. Awqaf South Africa, a charitable Awqaf organization, makes it easy to share the care. All donations are ploughed into Sharia-compliant investments, while the fruits support a wide variety of charitable causes. Visit awqafsa.org.za to discover how your Awqaf can bless our community with a legacy of care.
Good morning everyone, my name is Sororisa Makaila and I am the winner of the 2022 Okaf SA Online Matric Maths Workshop Competition. Yeah, that's quite a mouthful, but we will get into that later. I just wanted to make this short video to encourage and congratulate the matric class of 2023 for making it this far. We have been in the schooling system for 12 years now, and it all comes down to this. We are at the end of the year, which means that finals are starting soon, and the time between now and finals is very crucial in that you have to work hard and make sure that you are comfortable with what you've been doing this whole year and that you're confident walking into that examination room. And I can say confidently that by attending these workshops, you bring yourself one step closer to reaching your dreams, because they will do wonders to your marks. Only if you actively participate and ask questions. So please just make sure that you use them wisely, because they can really help a great deal in your marks. And having great marks in matric comes with a lot of great rewards. And speaking of rewards, Okaf SA is hosting a competition for the participants of these workshops. So you will have to send your final results and your June matric results to them next year in January. But like, you don't have to worry about that right now. Just be mindful of the fact that there is a competition that will be hosted by Awqaf SA. If you registered for these workshops, you will be sent an email after the final results are released. But just make sure that you enter the workshop when that happens. And finally, I just want to say good luck. Just grind. This is the final push. You're almost there. And I believe in you. You will make it.
And that's it. We've got a lot of things to do, but now currently it's break time, and it's Awqaf SA physics exam preparation workshop that is currently taking place in KZN at Falaah College. So we do want all of you to join us and let those who perhaps don't know about the program to join us, because excelling in physics exams, just got a little bit easier. So you need to join us for this comprehensive workshop hosted by Awqaf SA in Falaah College in association with Red Waqaf and iSkill. So the main focus of these exams, obviously, just to give a small debrief, is the past exam papers. We've seen students, on the online section asking us the same question as to which page are they using there. So it's not specific as to which page, because that really does not matter. What matters is that we do the methods, and the theorems, that are required therefrom. And the live stream is obviously available at Awqaf SA's YouTube and Facebook platforms. So you need to go to those platforms after the stream has ended. If there's something you missed, because some of the students were saying that the facilitator, Mr. Nikesh, is going a little bit fast. Because of time, we really cannot, go over in such a slow pace. So today we're focusing on physics, and tomorrow what you need to know is that we'll be focusing on chemistry. So today is the 23rd of September. We have been live since 9 a.m. in the morning up until 3 p.m. today. So we still have an hour, 15 minutes to go. And then we will have chemistry tomorrow, same time, same place. If you are online, you can go to the Awqaf SA's YouTube platform and the Facebook platforms as well. So those who haven't registered, they need to know that registration is essential, because when you have registered, there are a lot of benefits, that comes with you having registered. And one of them, as Rorosang had made mention, is the maths competition, which we will have in January next year, whereby you've got to submit your report, your school reports, that shows the progress. And then from there, the Awqaf SA will then choose who are the winners of those particular competitions. And we just saw now a testimonial from Roresam Matlaela, who is one of Awqaf SA's products, should I say. And he was telling us, about that. So we do need to take the advantage of this opportunity and boost, our exam preparations. So if you've got any questions, regarding this, then you can talk to Hassanain Abdullah. I think a lot of you know him very well. He is the project manager at Awqaf SA, and his email is hassanain@awqafsa.org.za. Or you can simply visit, Awqaf SA's website. That's where you can find most of this information, because this information is quite a lot. Imagine me, I'm just sitting here behind the camera talking to you, but it's a mouthful. It's a mouthful. But what about the students now? So you do have to make sure that you visit www.awqafsa.org.za and find more information about the things Awqaf do and so on. And the other thing is, if you really want to support, the Waqaf Education Fund, you can do so by scanning the QR code that I have put up on the screen as well. And I think now we are running towards, going back to session 3. If it was Mr. Coulter, he will refer to it as the graveyard shift, because everyone now, their stomachs are full and the mind is not functioning not so well. But you need to make sure that you put your utmost focus and remain intact, because that's the most important thing, as far as your studies are concerned. Now, yesterday we spoke to the district director, of education in KZN. We spoke to Miss Busi Mahlambi. Miss Busi Mahlambi was sharing, some advice, saying that it is important and essential for students, to open their books and make sure they use all the tools that have been provided by the Department of Basic Education, because the Department of Basic Education, especially, or should I say, specifically in KZN, issued tools, to try and assist learners for these final exams. So she ended up on a high note there, singing one of the songs, saying that noma ungayivula noma ungayivala kukuwe mntanami, meaning that whether you decide to open the book or you decide not to open it, it is totally up to you, because at the end of the day, it's your marks that online. So I think Mr. Nikesh is now ready to get us going. So now what we will do is we will cross to Mr. Nikesh, who will bring us the final session for today. Mr. Nikesh, over to you. Thank you very much.
You can carry on. We'll call them in now. Yeah. Learners all come in, please. Learners, please take your seats.
All right, welcome back. Hello to all online as well. Right, thank you, ladies and gentlemen. We're back online. We can start the session. We are going to look at now some chemistry questions, starting with organic chemistry and then leading off to the inorganic chemistry, which is the most important sections, I think, the rates and equilibrium and acids and bases. Right, now the question that I'm looking at for the audience in front of me is the question, it's towards the end of this booklet, it's right at the end. You'll find the heading, right, just let me show it to you on screen. Right, it says Falaah College Pre-Trial Exam Paper 2. There are some pages missing in this document, but the ones that are there are relevant to us. Now, if you turn over, we are looking for the multiple choice. Next to the multiple choice, you'll see the standard electrode potential table. Right? That's the question I'm looking at now. And I will use the larger version or the enlarged version for the online learners. All right, if we look at multiple choice, right, there are going to be 10 questions in your exam paper as normal. Right, from each chapter of the syllabus. Thank you. We must have some silence now and get busy. This is the hardest hour to concentrate because it's after lunch. Let's give it our best and try our best. We don't waste time. Settle, please. Settle down. Right, towards the end of the booklet, again, we generally start the exam papers with a level 1 easy question. An organic compound that's found in alcoholic drinks. Now, alcoholic drinks, the organic compound that's found there is ethanol, which is carbons, 2-carbon chain with hydroxide group at the end of it. These are called functional groups, by the way, people. We must know the definition of a functional group. An atom or a group of atoms that changes the physical and chemical properties of the organic molecule. Right? That question did not appear in your final exam, your trial exam, but can appear in the final. Right, ethanol. If you look at this molecule, this is what you've drawn structurally. But if you look at the bonds, right, it's CH2OH, or 1, 2, 3, 4, 5. C2H5OH. That's called the molecular formula. This is the structural formula. Now let's see if we can find it here. That is an alcohol as well. But it's not found in alcoholic drinks because that is methanol. That's methylated spirits. You drink that, you'll die. Okay? That's definitely a hydrocarbon. It's not an alcohol. There's answer C. C2H5OH. It matches what I've drawn, C2H5. So the answer is C. Number 2, in which of the alternates are the 3 compounds listed in order of increasing boiling point? Now, if you're saying increasing boiling point, you start with the weakest intermolecular network to the strongest. The weakest network is London networks, or induced dipole. I think most teachers now use London forces, right? Or dispersion forces as the weakest. London forces followed by dipole, van der Waal forces, followed by the strongest networks are hydrogen bonds. Now remember, these are not atomic bonds, these are molecular networks. I prefer to use the word molecular network instead of saying intermolecular forces, because many learners think that the bonds here in the carbon to carbon is the network. That's not. This is atom to atom. That's a covalent bond. A network means one molecule, if I can use my fingers, one molecule joined to the other one. See, like that. This is methanol or ethanol. This is also ethanol. They're linked together. That is called a molecular network. Right? The atoms are all my fingers in between. But when one molecule links to another, you get a very strong network, right, where they're very tightly packed, called a hydrogen bonded network. Or loosely packed, slightly loose, dipole van der Waal. Or the weakest of them all is London forces, where the networks hardly have enough surface area to attract each other. Right? And the weaker the network, the lower the energy required to change phase, the lower the boiling point or melting point. That's the rule. Right? Whenever you talk about boiling points, melting points, you talk about 3 things: type, strength of the network, and the energy needed. Those 3 things are compulsory. And I see now in our exam papers of late, they're also talking about VP, vapor pressure. And vapor pressure is the direct opposite of boiling points. The higher the boiling point, the lower the vapor pressure. If you're comparing molecules, like if you look at your question here, these are all organic molecules. In which of the following alternate molecules are the 3 compounds listed in order of increasing BP? So we look at London going to hydrogen bonds. Now this already, pentanoic acid is hydrogen bond. Pentane is London. This is out. We must start with London. B is also hydrogen bond. That's out. C, pentane, London forces. Pentanol, hydrogen bond. Pentanoic acid, also hydrogen bond. But which hydrogen bond is the strongest bond between the same chain length? Pent and pent is the same. But this is pentanol, but this is pentanoic acid. Pentanoic acid has 2 sites. 2 sites for hydrogen bonds. But alcohols only have 1 site. So your answer here is C. Weakest network, second weakest because 1 site of hydrogen bonding, strongest because of 2 sites for hydrogen bonding. Option D starts with London forces, then it goes to pentanoic acid, the strongest network in all molecules, followed by the second strongest. So it's the other way around. So the answer is C. 1.3 is level 1. Right? Level 1 question, you must know this. How to produce esters. Esters are organic acid plus, I call it organic base, because alcohols have hydroxides. Hydroxides are basic compounds, but it's got a carbon. So organic base alcohols with carboxylic acids, C double bond OOH, carboxylic acids with alcohols give you ester and water. With the catalyst, heat and conc sulfuric acid. So the only option that matches our general equation here is option D, carboxylic acids and alcohols. Right? 1.4 deals with rates. Now, factors that influence rates, right? Factors that influence rates are temperature, concentration of solutions, right? Surface area of solids, right? Surface area of solids, right? Use of catalysts, positive catalysts. All these, an increase in temperature will increase rate, an increase in concentration of an acid will increase the rate, an increase in the surface area by crushing the solid into powder. Many of us do not say that. We say just increase surface area. You don't tell us how. You must say increase in surface area by crushing into powder will increase the rate, and use of positive catalysts speeds up reactions to increase rate. Remember, you get negative catalysts too. They slow down reactions, so make sure you write the word positive. Now, in our scenario here, magnesium reacts with sulfuric acid to liberate hydrogen gas. Magnesium reacts with sulfuric acid. Now, learners, you are in grade 12. You are expected to write these equations from your head. You should have done this in grade 9. Any acid reacts with a metal, gives you a salt and hydrogen. Right? You must know this. Now, that's the equation. Which of the set of conditions for the sulfuric acid will ensure the highest rate? Highest rate means, we come back to our factors. It must be the highest temperature, highest concentration. It must be a powdered solid. Normal in the solid phase must be powdered or crushed. And if there's a catalyst, which they never mentioned, they're using a catalyst. So which of these four options here will give you the highest rate? 20 and 20 is out, but there's these two. See, these are called distractors. They are out. Now it's between C and D. 40 degrees Celsius, very high temperature. 100 volume, 1 mole per liter concentration. But D's got the same temperature, the smaller volume, but double the concentration. So the answer is definitely D. If you double the concentration, you will increase the rate. And at 40 degrees, higher temperature compared to 20 and 20, you double the temperature, you increase the rate. Volume is not a factor. Volume is an independent factor. It is not a factor that influences rates. There's my factors here. The fifth factor is pressure. But this only deals with all objects being, or all substances being gases. Right? We cannot talk about pressure in this equation because magnesium is a solid, sulfuric acid is aqueous, magnesium sulfate is aqueous, and this is a gas as well. So you cannot talk about pressure influencing this system because this system does not have all gases. So the four factors that influence this system are these four. Okay? Please do not confuse this section with equilibrium. There's a single arrow here in the equation. A single arrow means that this is not a reversible reaction. So the system is not closed. It's an open system. The gas escapes after production. I hope you are familiar with that. So a way of gauging difference in rates from difference in equilibrium, look at the equation given in the question. If there's a double arrow in that equation, it's chemical equilibrium, where the rates are equal. If there's a single arrow, you're simply talking about reaction rates and the factors that influence it. This is a very easy section to get marks in, but unfortunately many learners do badly because it's right next to question 7, equilibrium. You'll mix the two up and you'll get it wrong. This only influences the rate of the reaction, that's all. Nothing else. Right? The next page, I think there's more multiple choice. 1.8, I think it starts with. The others are not here, they're missing. Yes. You're looking for this page now, ladies and gentlemen? Right, the periodic table is there next to it, and there's the question. I will put in the enlarged version for the online learners. Right? Okay. 1.8. The standard cell notation for the zinc copper cell. Now, zinc and copper. The zinc copper cell, when you design your standard cell notation, it is standardized. Standard means you can't disobey what you have been taught. We are governed by the ANC in South Africa. There's it. Anode, salt bridge, cathode. Never forget it now. You can't forget it if you live here. I'll be amazed if you get it wrong now. Remember ANC. So the anode is on the left-hand side, the cathode is on the right-hand side. You'll never, ever, ever go beyond that or change that thing. You're getting a mark for writing salt bridge like this already, leaving 2 blanks. So you can't fail this thing to ask you for standard cell notation. Now the problem is selecting the anode and cathode between zinc and copper. Now that's very straightforward. Very straightforward. Your data sheet is of great value to us. This is a very important tool. Right? If you look at our data sheet, right? Zinc is there. Remember, this is not zinc. It's the zinc 2 plus iron. That's how you speak. That is called zinc on the right-hand side. That's the metal. So when you are discovering or using this metal, this table to convert back into English in words, do not use the words zinc. I'll mark it wrong. Matric markers will mark it wrong. You all had this question in the trial exam where we had to compare oxidizing and reducing agent strengths. People are talking about zinc. Both of these are called zinc. So when you use the word zinc, I don't know which zinc you're talking about. As a marker, you get 0. If you're talking about the left-hand side, you'll tell me zinc 2 plus. What you see, you write. You saw the Zn, you saw the 2, you saw the plus. Write what you see. On this side, you see zinc. Zn is on that side. That is called elemental zinc. I want to see this word. Because if you don't write it, we're marking it wrong. I'm being serious, ladies and gentlemen. Check the memo. Check the memo that you wrote your trial paper to. They are very clear when they use cation, anion, elemental zinc, and things like that. They don't just mention things in fresh air. Check the memo. There's no alternate answer. If you don't like the word elemental, you put in brackets S for solid. You don't like the word Zn2 plus, you say zinc aqueous. Now I know you talk about the iron. If you don't do it, it will be marked wrong. Another warning I'm giving you. Right, anyway, that's zinc. Copper 2 plus is somewhere down here. Now if you look at copper 2 plus, it's very dangerous. There's a copper plus 2 going to elemental copper. There's a copper plus 2 going to copper plus 1. You must be careful of the copper equations. I think there's one other equation for copper. Right, there's a third one, copper plus 1 going to copper 0. Now in this case, we are talking about copper plus 2. So we look for copper plus 2 reducing to there. So there's your 2 equations. Now we as teachers teach, when you select your 2 equations, zinc and copper, reverse the top one, and that will be the anode. Now, that is the shortcut method of teaching. In exam papers, we ask you why you reverse the top equation, and the answer is yeah. Zinc has a lower E0 value than copper. If it has a lower E0 value, it is a better reducing agent. I don't like the word ability, I prefer the word agent. If it's on top, it's a better reducing agent, not it's on top too. Elemental zinc is a better reducing agent than elemental copper, is the answer in a memo. Not zinc is better than copper, or my teacher said reverse the top one. All marked wrong. You must, remember, you are ladies and gentlemen, I addressed you as that. You are adults. You cannot write baby language and expect marks. Get that through your heads, please, for all subjects. You can't write like a baby. You may think like a baby, but write like an author. Right? So, if that's reversed, that's the anode, that's the cathode. If you reverse that thing, zinc, let me write it, if you reverse the zinc equation, zinc becomes Zn2 plus, releasing 2 electrons, it's called oxidation. Right? The moment you release electrons on the right hand side is oxidation. But copper ions, you don't reverse, you leave it as it is, gains the 2 electrons zinc lost to become copper solid. And here you can say from 0 it increased to 2, that's oxidation. Reduction is a decrease in oxidation number from 2 to elemental objects which are 0. So that's reduction, that's oxidation. So doing your standard cell, you put anode, salt bridge, cathode, draw your salt bridge for 1 mark first. The anode, zinc becomes Zn2 plus. Zinc 0 becomes Zn2 plus. Aqueous, concentration 1 molarity. You're supposed to be writing all that. You're supposed to write that. This is zinc solid. You're supposed to write all this. All right? Copper 2 plus became copper 0. Copper 2 plus. This slash shows a phase difference. Change of phase. From an aqueous, it became a solid. That separates the phases of matter. They may ask you, what's the function of the slash? To separate the phases of matter. And that is the standard notation, right? Again, you're supposed to write concentration is 1 molarity, right? At 25 degrees Celsius too. Because you don't know what the marker is looking for, you write everything, right? Now, the answer obviously in the multiple choice, I know it took me long, but it's important to understand how to use this table. This table's got all the answers for question 9 and 10. But if it's incorrectly used, you're going to have a lot of problems and you might lose 37 marks. Right? The other thing about the table, make sure you're using table 4B in KZN. We do not use table 4A. You make sure you use table 4B in KZN. Right? So the answer for the multiple choice, we got the answer here. You started with zinc 0 to Zn2 plus and copper 0 to copper 2 plus. So let me just find the question quickly. All right, so 1.8. You've had the question in front of you. What's the answer? It's definitely D. Hey, not D, sorry. C. Wait. Zinc, hold on. Zinc 0 to Z. There's it here, man. It's B. This is all nonsense. I got confused with the tail end. This is nonsense too. See, even we can make mistakes by looking at the end. You look at the whole thing. Right, the answer is definitely B here. Right, and by the way, from the standard notation, you can get all the other equations. I hope you realize that, huh? You can see Zn became 2 plus. So Zn became 2 plus. And if you go to the data sheet, you'll see it's the other way around. That means this was the anode, it's correct. And copper, you can see, from the salt, you see a redox reaction, people, in a simple language, simple English. A solid dissolves to a salt at the anode. Can you see solid became a salt? At the cathode, the salt becomes a solid. The opposite happens. In one part of the beaker, the solid dissolves, but in the other part, the solid increases in mass. And this is true for all batteries, galvanic and electrolytic. It is a common feature. At the anode, it always will corrode, dissolve to make a salt. There's it. All anodes will dissolve if they're metals. Number 1.9, there's it here. Electrolytic battery. Why is it electrolytic? Right? They say refining of copper. Now, if you are refining to make copper, right? When you're refining copper, you must have copper in both sides of the beaker. One side will be pure copper, the other side will be impure copper. You can't have copper here and zinc here. That makes sense. There'll be copper in the entire beaker. Copper, impure copper called the ore. I think you heard this word before. That's how you find metals, ores. And the pure one will obviously be this. This is pure or elemental copper. Right? The salt will be a salt of copper too. Copper 2 sulfate. Sludge is the impurities. Because an ore is actually a rock. In that rock you could have other metals. Calcium, zinc, whatever. A platinum, gold, silver. But this industry is only worried about purifying copper. So what happens in this battery is very simple. There's pure copper stuck in here. In the ore, there's always pure copper, not the salt, pure copper. That copper will dissolve into a salt and become ions. So that copper becomes copper 2 plus, becomes a salt. This electrode will always be negative because a negative electrode will attract the positive ions and get it stuck there to produce the copper. So the copper 2 plus gets attracted to form elemental copper, and this will get fatter and fatter and fatter because pure copper is deposited. Copper deposits. And this can only be the cathode. You see, before you do an exam paper, when you're studying these diagrams, don't look option A, B, C, D. That's all nonsense. Don't look here. You need to understand the question first. What is going on in this battery? Now you can go and choose the answer, it becomes child's play. You can't just pick and choose. You got to do some introspection. Do some detailed studying in your reading time. And now that we know that's the cathode, this is the anode. And correct, the anode always dissolves. Correct, I just told you that earlier. There's it, dissolve the copper into its salt. Right? Now what happens is the rate at which oxidation occurs here is equal to the rate at which reduction of the copper ions occur to form pure copper, so that the cell stays in equilibrium and the concentration here don't change. Concentration is constant. For every one that comes out, that one now it attracts to the cathode. And that's the most important thing here. In an electrolytic cell, the cathode is negative, the anode is positive. In a galvanic cell, it's the other way around. Make a note of it. Electrolytic cells, the cathode is negative. In a galvanic cell, the cathode is positive. Right? But the rest of it is the same. The anode is the electrode where oxidation occurs. The cathode is the electrode where reduction occurs. Those things never change in any battery. Right? Which half cell occurs, which reaction takes place at X? X is the cathode, reduction has to be C. Copper 2 plus gains 2 electrons, become copper. There, I wrote it next to it. There's it here. There's it. The ions are attracted with 2 electrons to become pure elemental copper, and it gets fatter. Right? 1.10 is not in the syllabus anymore, so I'm not even going to go bother with that. Okay? Our next question in our booklet is some organic chemistry. Now, organic chemistry is a learning subject, people. A learning subject. We're going to the next page. I'm talking about this page here. Ladies and gentlemen, question 3. Right? I will do some organic naming compounds as soon as I finish all this. Question 3 is about isomers. In other words, theory of organic compounds, not balanced equations. Now, I'll use the larger version for the online learners. As I said, while you are talking, you're talking over me. Organic chemistry is a learning subject. You've got to take your notes and learn it off by heart. There's no thinking involved. Alkane plus halogen gives you haloalkane plus halogen acid. Memorize it. Hydrocarbons react with oxygen to always produce carbon dioxide and water vapor. In excess oxygen, they burn it. Number 2. Number 3, carboxylic acids plus alcohols will always produce ester and water. See, by heart that thing. Because you are not going to get specific alcohols. Ethanol will not come out in any exam. Maybe pentan 1-all will come out. In term 4, this term when you are writing, maybe butan 2-all will appear as an alcohol. Butan 1-all was in your paper. So you don't know which alcohol will come out. You learn the general statement of the reactions. There are 13 reactions. You learn them all for only 6 of them to come out in the exam. You know all of them. If you miss out one, you can kiss your marks in question 4 goodbye. Fortunately, this term it was struck off, isn't it? It's not going to happen again. Let me just burst your bubble. They're not striking out anything again. It was your lucky day, if you can put it that way. Your luck has run out now. Number 1, what is the structural isomer? That's in the CAPS document. Structural isomers are organic molecules. You've got to say this first. What is an isomer? It's an organic molecule, organic molecules that have the same general formula. CnH2n plus 2, CnH2nO2, all that. Those are general formulas. They have the same general formula, but different structural arrangement of the atoms. But different structural arrangement of the atoms. Right? Different structural arrangement of the atoms surrounding them. Now, you don't have to take this surrounding, or just leave that out. Different structural arrangement of the atoms. You don't take the definition from me. You go home and by heart the guideline document is 36 pages. Go and find that document and learn every page. It is now time to learn it. If you haven't learned that guideline document, you're going to lose 20 marks in each paper. 10 definitions in paper 1 and 10 definitions in paper 2. So if you want to start your exam out of 260, you're going to lose the 40 marks. Other learners want 300 marks. Go and learn those definitions. If you don't want to learn it, it is your fault you chose physics. I didn't force you. Neither did anybody else. Right. We are adults, we have to think like adults. You know, be a baby, find another place. Compound A has a lower vapor pressure than B. Firstly, this is a general formula. We can derive the general formula from here as CnH2nO2. When you double the carbons, you get the hydrogen number, and there's O2. So they're all even numbers there, right? And they will not be even. You get C3H6O2. 3 is not an even number. This describes 2 functional groups. It describes esters and carboxylic acids. So if I asked you to represent C2H4O2, you draw it as an ester with the ester function. Then you draw 2 carbons as a carboxylic acid with that functional group. Do you understand? Now between these 2, this one's got the strongest intermolecular forces. Please, many of you are not writing this. You're saying strong hydrogen bonds. I'm comparing 2 of them. This is the strongest compared to this. You're going to write that. This has the strongest intermolecular network compared to esters who have weak dipole van der Waals forces. It's a lot of English to write for one sentence. It's only 1 mark. You're writing so many things. Carboxylic acids have the strongest intermolecular network called hydrogen bonds compared to weak van der Waals forces in esters. 2 marks for all that. Now, they didn't even ask you this. They asked you about vapor pressure. How is the strength of the network related to vapor pressure? The stronger the network, the lower the vapor pressure. So carboxylic acids have a lower VP than esters. Many of you forget that word, than esters. What happened to the vapor pressure? Lower than. Lower than what? Lower than the ester you're talking about. You just don't write lower than. Marked it wrong. If you were given the marks in school, you're going to lose it end of the year. Your answer must be like the memo. I repeat, like the memo. No lenient marking at all. These papers are national. You are called candidates. We're not playing games here. You're no more a child, you're a candidate. You come in there with your ID. We have to respect that. As examiners, moderators, teachers, we got to respect you. You are a candidate with an ID. When you leave that venue, that's the first thing in life you'll own. The marks on your certificate. Because right now you own nothing. The first thing you own will be your matric certificate. Remember that. For life. And it won't change. So take your life seriously. Because I certainly do take mine. So, lowest vapor pressure, higher boiling point. If it's got a higher boiling point, the network is tight. Tight network, hard to pull, lots of energy required to change phase. So higher boiling point. How will there's it now. How will the boiling point of A compare to that of B? So we said A has got a lower vapor pressure. A will have a higher boiling point. First answer. Write down the name of compound A. Now we already discovered that if it's got a higher boiling point, it's got a stronger network. Between ester and carboxylic acid, who's the stronger network? So we need a carboxylic acid with 2 carbons, and there's only one answer, ethanoic acid. The name of A is ethanoic acid. Only ethanoic acid is C2H4O2. Right? A has to be the higher boiling point because it's got the stronger network and it has a lower vapor pressure, 100% correct. Now if you put the ester as your answer here, you lost all these marks in the end, all gone. So out of 11 you might get 2, the first 2 marks. So please be very careful when you are learning your general formulas. It is imperative that you know this one describes esters and carboxylic acids. However, there's another funny one like that. But there's a single oxygen. This general formula describes 2 organic families as well. Aldehydes and ketones. You must know this thing. Because anything that is confusing to the learner is going to be set. This is CnH2nO. This one is CnH2nO2. Confusing you? Yes. Will they set it? Definitely. You can't be hiding from the truth now, ladies and gentlemen. They're coming for you. You must be ready. Okay. Which class of organic compounds does B belong to? Obviously, if that's acid, this has to be ester. Write down the structural formula of B and give its IUPAC name. So for B, right, it's 3.2.3. Let me write it here. 3.2.3. It is an ester of C2H4O2. So the ester functional group, now we in Overport. So I taught this to my class. Overport City. You can go either side. Overport City. That's the functional group of ester marked wrong in the exam that you just wrote. Because every carbon must have 4 bonds. 1, 2, 3. Now that's the general formula of the functional group. Now you get 1 mark. You missed all these, I call them sticks out, not. So 2 carbons, 1, 2. 4 hydrogens, 1, 2, 3, 4. Oh, and there's the 2 oxygens. There's it. And name it. The aryl group, you block that. The aryl group is from the single oxygen and the carbon. How many carbons there? So it's methyl. The aryl group is named with the single oxygen and its tail. The double bonded oxygen names the O8 group. How many carbons there? So it's also meth. It's methanoate. So that is your answer for the 3.2.3. Draw the structure and name the ester. So 1 mark for name, methyl, and 2 marks for the drawing. Any mistake you get 0 out of 3. Any mistake. You can spell wrongly and lose that mark here, but get that 2 then. But if you made a mistake here, put an extra hydrogen or carbon, we don't even look at this answer, it's wrong. You can't take wrong carryover. You're not. Metric is a different kettle of fish. It's not classwork. It's not a school June exam. It is a national paper with national marking standards. Right? Next one, 3.2.4, write down a structural formula for B. I think we did that. Yes. Explain in terms of intermolecular forces. Explain in terms of intermolecular forces and energy why A has a lower vapor pressure than B. Now, there are many ways of doing this thing. Many ways of doing it. Right? You can talk about A only and compare to B in the end, or talk about B and compare to A. So one of the two. But the answer must have something about forces and something about energy. So if you look at compound A we said was ethanoic acid. So what do you talk about A? Right? 3.2.5, molecule A. You don't have to say ethanoic acid all the time, just talk about A. A has strong H bonds in molecular network compared to weak dipole. Now many learners write London forces here. When it comes to esters and aldehydes and ketones and haloalkanes, they're all dipole networks. The London networks are only found in hydrocarbons, C and H's. Methane, butane, propane, propyne, all those got London. Carbon, the hydrocarbons are all London. All the others are either dipole. There's only 4 dipole. The aldehydes, the ketones, the esters, and haloalkanes. And the last 2 are alcohols and carboxylic acids, which are hydrogen bonds. It's easy, this thing. There's only 11 families. It's easy. Weak dipole. Van der Waals forces. Therefore, more energy needed to weaken IMF in A than B. Therefore, higher boiling point in A, lower. Many of you are writing high boiling point. Higher. You write high, mark wrong. You haven't got the ER there, we mark it wrong. The memo does not have the ER missing. It doesn't say high boiling point. High compared to who? You didn't say it, you didn't finish it, mark wrong. Higher boiling point in A, lower vapor pressure. Now you're not allowed to write like me. In code, IMF and A and B, you're going to write BP, you're going to write boiling point. So in molecule A has, let me go back to the top there, right. A has stronger hydrogen bonds in the molecular network compared to the weak dipole. So you told the examiner, this guy's got strong, this guy's got weak. You named the network too, dipole, hydrogen, right? More energy needed to weaken the IMF. Don't say break the bonds. No bonds get broken anywhere. There's no such thing as breaking bonds. You weaken a network. You can't break any bond. You break the bond in a chemical reaction in a balanced equation. This is not a balanced equation. This is melting and boiling points. Properties of organic compounds. You don't break bonds. You weaken them. Right? To weaken the intermolecular forces in A than in B, higher boiling point in A, therefore lower vapor pressure. Now, why did I include the vapor pressure? The examiner asked you to comment about vapor pressure. Right? Many learners will write higher boiling point, they forget this. The examiner asked about pressure. You talk about boiling point. Why? Too many past papers. Every past paper got boiling point. Final exam going to have melting point. You know about melting point in the end of the year. In brackets I put S. Butane S. That means solid. Don't talk about butane melting or boiling. Talk about it melting. Solids melt, liquids boil. They're assuming here that A and B are liquids. That's why they talked about boiling point here. So melting point doesn't come out. It's the same answer. You write the same thing. But instead of boiling point, you write melting point here. And you won't talk about vapor pressure in a solid. Please. You're insulting me now. Okay? You talk about vapor pressure of a gas. Vapor is a gas. So go and learn the definition of melting point. It's quite a challenging one. Melting point is a temperature point at which the solid and liquid phases of matter are in equilibrium with each other. Go learn. Right, next question. We're continuing in this booklet. Right, we're looking at this question here, ladies and gentlemen. Our favorite question again, reaction rates. But this time it is graphical. Right? I think we had a graph in our paper, if I can recall. Yes, we did. And the sad thing is learners can't read from graphs. How sad. Right? For the online learners, right, you are recording this so you can see the question clearly as well. A group of learners do an experiment to investigate the rate of a reaction. They use granulated zinc to excess acid. First thing is that's excess. So immediately you go write this, LR. Limiting reagent is zinc. What does that mean from grade 11? The reactant that is completely used up in a chemical reaction, it's finished. So when this finishes, the reaction will stop, and then it stops here. Reaction stops when the line is flat. Not what you guys did in the trial. You have said this is equilibrium. When the line is flat, equilibrium is established. How many arrows here? How can you talk about equilibrium in a single arrow equation? You can't read. You failed all question. If you mentioned equilibrium with this single arrow, you get nothing. Your answers are all absurd. So be very wary, ladies and gentlemen. Look at the question, look for the arrow. You're talking about equilibrium here, goodbye. That's the end of you. Right. The hydrogen gas is connected at 290 Kelvin by measuring the volume of the gas produced. So the gas is here. Many of you don't read that there's a phase of matter there. So they collected the gas. You can't collect this, very hard to collect this. The easiest thing to do is measure the gas collection or measure the mass decrease in the solid. That's how you determine the rate. You decrease the mass, measure its rate at which it decreases, or you increase the volume of gas collected. Or you can measure the mass of this too as well. Right. So initially, oh by the way, I don't think many of you realize this. Anytime a metal is burning with acid, acids burn metals. Remember the word burn now means what? What it means, burn. This reaction is exothermic. That's why the rate is so high initially. And this question was asked in your trials. Why is the rate high in that section? And the answer is, beside you have a lot of product, there's still a lot of reactant in your test tube. It's still decomposing, right? And the more decomposes, the rate will increase, agreed? But it's also decomposing under extremely exothermic reaction. So temperature has increased and rate has increased was the answer in the trial exam. So you have to talk about the temperature change here, increase in T, not number of moles, not concentration, temperature. Your trial exam was tricky. So now you learnt it from me. Any metal destroyed by an acid is an exothermic reaction, grade 10 work. Grade 9s, my grade 9s know this. Right? What is the gradient of the graph? The gradient of the graph will always give you rate. Reaction rate. I think that's too generous for 2 marks. The gradient, if they talk about the gradient, let's work out the gradient. Gradient is equal to delta V all over delta T. The change in volume will be V2 minus V1 all over T2 minus T1. So we're looking for 2 coordinates on this graph because I need 4 numbers. Right? We need to find 2 coordinates. Describe how the gradient changes between 100 and 200. Now 100 and 200 is this section here. What's happening to the gradient? If you draw a tangent there, a tangent here, a tangent here, a tangent there. What's happening to the slope of your tangent? Decreasing. So rate is decreasing. So the first thing is you say gradient is rate and it is decreasing. Why? Why is it decreasing at this times? Because of this. There's your answer, yeah. What's happening to your limiting reagent as time goes by? It's being used up. You get less moles of zinc left in the test tube, less collisions per second, less effective collisions per second, decrease in rate. I want all 4 for 4 marks. I want everything. Okay? As the limiting reagent is used up, there are less moles of zinc. Right? If there's less moles of zinc, there are less collisions per unit time. In this case, it was per second. Per second. Therefore, there will be less effective collisions per second. Because not all collisions are effective. Remember that. You must use the word effective. So there will be less effective collisions per second, rate will decrease. Okay? I'll give you the whole 4 marks. The examiner only asked it for 2. Right? Okay? 2 marks. Give a reason. I gave you 4 mark reason. It's 5.3. Why does the graph become flat at 300 seconds? Right? There are many answers. The reaction stopped. All the zinc was completely used up. The limiting reagent zinc was finished. But not equilibrium. You write equilibrium, goodbye. Right? 5.4, calculate the rate in cm³ per second for the first 100 seconds. So for the first 100 seconds, yes. So, there it is there. So the coordinate at the top, when x is 100, y is 150, I think. And the easiest coordinate to take, people, is the origin, man. X is 0, y is 0. Now some of us are bad in algebraic maths. Please write, that's V2, that's V1. If that's V2, that's T2, that's T1. Because when you come to the gradient formula now for 5.4, right? When I'm doing the gradient formula for 5.4, I told the teacher it's already rate is the gradient, delta V over delta T. Now those of us who are bad in maths, go and write it. Expand it. There's no marks for this, by the way. But you want full marks, you do it. V2. Now you go to your question and you see, hey, V2 is 150. V1 is 0. Because many of you are going to write the V's on this side. I don't know why. Delta X over delta Y, not delta Y over delta X. This is delta Y and that's delta X. That's the gradient formula. Right? So V2 is 150, V1 is 0, T2 is 100 and T1 is 0. So your answer becomes 1.5. Now the unit, the volume is in cm cubed slash the second. There's the unit there. Take it from your equation, it's maths. Cm cubed slash second. And you should get, what, 3 marks or whatever this is, I don't know. 3 marks. So mark scheme. What they ask for, calculate the average rate. Yeah. 1, 2, 3. No mark for this. Right? Okay? The other thing I want to point out, by the way, just let me show you this again. In 5.4, there's somebody talking, this word can change to instantaneous rate. Now how do you do that? Level 4. You're coming here for level 4. I'll put it there on a board now. How do you do instantaneous rate? You know these 3 words, people online and in front of me. You must say it loudly. My class says it. I don't know. Good. When you do that, then you start learning. Don't pretend you know everything. Now give me the answer if you know. You kept quiet, now you're saying you don't know. Do you know or you don't know? You don't know. Good. This side here knows it. So this side here, gentlemen, tell me the answer. The boys seem to know everything. Also don't know. Right, let me tell you. When they give you a graph, let's say they give you the zinc being used up versus time. Now zinc being used, mass of zinc versus time, the zinc gets finished, okay? If I ask you the instantaneous rate, you pick 2 coordinates, so the examiner will tell you between 1 and 2 seconds. So let's say that's 1 second, let's say that's 2 seconds. You take a very small time interval, usually 1 second or less, and draw a tangent to that 2 points. What you draw? And you find the gradient of that tangent, that coordinate at the top, that coordinate at the bottom. So you are finding actually the rate at an instant in time. Is that clear? Understand? You draw tangent to those 2 coordinates. A very small time interval, delta t, and you find the instantaneous rate. Right? Next question. Use the collision theory to explain what happens when temperature is increased. Now, be guarded by the mark scheme. Some examiners put 3, some put 4. Right? I think I got a memo for this thing. I don't want to write, my hands are paining now. Hey, this memo is not good enough, man. I don't like this memo. Right. High temperatures mean the reactive particles have more kinetic energy. Right? I don't like this thing because I think this memo here is too short. It should have been more. When your temperature increases, each particle gains kinetic energy. I stress I want that sentence. Each particle gains more kinetic energy. Right? So, if they gain more kinetic energy, what happens to their speed? They increase. And that's your second mark. The speed of the molecules increase. Right? And when the speed increases, the number of collisions will increase per unit time. Therefore, the number of effective collisions per unit time will increase. Therefore, the rate will increase. That's what I want. Okay? This doesn't even talk about what I've mentioned. The speed of each particle increasing. You must write that, please. When the speed increases, you get more collisions. Therefore, more effective collisions. Then rate will increase. Right, 6.6. Right, the gas liberated was collected at STP. Now you must know this. The gas liberated is hydrogen. Calculate the mass of zinc that was used. Now, when you did stoichiometry in grade 10, your teacher said when it comes to story sums like this, select the two relevant chemicals. So it's zinc versus hydrogen. Step 2, write down the mole ratio. That's 1:1. Step 3, divide your page into 2 equal halves to write down information. So your teacher wants mass of zinc. Put it as fresh air. You don't know. But the molar mass of zinc is 63.5 from the data sheet. Right? Hydrogen gas, they said STP. Molar volume at STP is 22.4. Please note, the examiners are now changing this number. They're putting 30.8, 26.57, 21.11 because the conditions of STP have changed. They write it and they say standard molar volume is now 30.11. Do not use this if they say standard molar volume is 30.11. Now why learners use this? You don't know this means in English standard molar volume. You call it VM. Learn in English, it's called standard molar volume. So V is missing, N is missing, N is missing. You got a lot of problems here. That is why you failed this question. There are too many missing values because step number 5 is work from known to unknown. Unknown, 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 unknown. 4 unknowns, 2 on either side. You can't use any equation. N is equal to V over Vm. You can't use. N is equal to baby M over big M. You can't use. There's too many unknowns. So we leave it blank and get 0. That's what you'll normally do. Because, you know why you leave it blank? I've never seen any learner in my marking career of 21 years ever leave this blank. You know why? They've got a problem solving strategy. Learners who leave it blank haven't got this written down. They got it blank. If you write this down, you'll understand you need one value on either side and you get 5 out of 5. Any side you have here, you put one number, you get full marks. And the answer is in the graph. There's the value here. That's the amount of volume you collected out of gas. There's it. You can't read. Your analysis, interpretation of questions is poor. You forgot there's a graph with information. There's it here. 250 cm cubed, which is called volume. There's it. But it's got a dangerous unit, 250 cm cubed. All you do is put times 10 to the minus 3. The moment you put times 10 to the minus 3, the cm cube became dm cubed. And now the rest is maths. So I'm going to do it on this page because I got no space there. 5.6. So I got hydrogen. Let me just divide that. Hydrogen versus zinc. Step 1. Number of moles is V over Vm, which is 250. 250 times 10 to the minus 3 divided by 22.4 and you get an answer. But the ratio is 1:1. Please make sure all of you are selecting your 2 relevant species that are involved with the relevant balancing numbers. You're getting marks for this now, people, because we know you're messed up here. But if you got a ratio, for all this we give 1 mark for trying, 1 out of 5. Better than getting naught, because the child comprehended the correct question. Fair, we're being fair to you now, am I right? So step 2, mass is equal to N times M, but number of moles here, what was the answer? 0.11, 0.011 moles. Since the ratio is identical, if that's 0.11, to be 1:1, this will also be 0.011. So mass will be number of moles times molar mass, which is 0.73 grams of zinc. Right? So it was worth 5 marks. Okay? This is definitely 1 tick. Answer is definitely 2 marks. Do I mark this formula here? Step 1. No. No mark. There's 1. There's 2. There's 3. There's 4. When I underline this, it means you carry that down with this. When both these are correct, then I give that tick. You can't have a wrong answer here and I mark it right. This has to be 0,011, not 0, something else. So if you got it wrong here, I mark this wrong and that wrong. This has to be right to get this tick. No answer. No story. So 3, 4 for ratio, 5 for this. Now the danger, people, if you didn't convert this thing, you get 1 out of 5, you write the supplementary, you failed. If you didn't write this, you get naught, because we're not marking formulas anymore. Please note, there's no mark for formulas. You'll see when you get your marks next term, what a shock you're going to get. There's no marks for formulas. Because people are getting ticks here and passing the paper. Write all nonsense and get ticks for the formulas. Not anymore, now you're failing. Right. The formula is given 1 mark only in a multi-step calculation. Remember that. And it's given no marks in a single step. We're marking figures now. Right? Right, next booklet. Next question. Let's see what we've got here. Right, we've done the rates question. We've done the molecular formula question. We did that, and we did a multiple choice. Right, I want to look at, before we go off, I want to look at one more question which is not in this book, but I will give you from mine. Okay? Because the printer I think skipped pages for you guys. Okay? Our friend. Right, you'll need to take this question down, people. KC calculations. Right? And chemical equilibrium. Now you can see, question 6, there is a double arrow. So this means chemical equilibrium in a closed system. A closed system. Chemical equilibrium. The rate of the forward reaction is equal to the rate of the reverse reaction in a closed system where all concentrations of reactants and products are constant. That is the definition of chemical equilibrium. What is the definition of the word reversible? Define the term reversible. When the reactants can become products and the products can become reactants in that system. What is the meaning of the word dynamic? Chemical equilibrium. What is dynamic? Go learn. I'm not telling you everything. You must learn like how I know it. Go learn it. Can't spoon feed you. Right. This is the Haber process. You don't have to know that. You need to know this. Exothermic reaction. That means heat is a product here. You can write plus heat. So whenever nitrogen and hydrogen combine, heat is released with ammonia. So the ammonia is hot ammonia. It's hot. Right? That means that vessel, that test tube, that container, that 10-liter flask, the 200 million liter flask is hot because the reaction releases a lot of heat. The percentage yield is the amount of products. Increases with increase in pressure. Give a reason why. Now I'll write it here. N2 plus H2 produces 2NH3. So 3, 1. So these are all gases. Make sure it's a homogeneous system. Opposite homogeneous, heterogeneous. Homogeneous means same phase of matter. All are gases. Total the gases in moles. How many moles on the left hand side in total? 4. How many moles on the right hand side in total? 2. So an increase in pressure will always favor the reaction towards the lower moles. That's what we are taught. That's what you are taught by us. When you increase pressure, it favors the reaction towards the lower volumes or lower moles of gas. And that is exactly what you write for 6.1. And in this case, the forward reaction is favored from higher moles to lower moles. Please notice, this is only for gases. Right? Make sure you total the moles of gases when you talk about pressure. Do not put the solid and liquid. Okay? You leave it out of the mole ratio. Only gases. So that's the answer in the memo. An increase in pressure will favor the reaction where towards the lower moles. In other words, the forward reaction is favored. 2 marks. Right, now we come to our story. A mixture of nitrogen with an initial conc of 0.5 and hydrogen with an initial concentration of 1.5 is placed in a 1 liter vessel. I like that, 1 liter. Right? When equilibrium is attained at a certain temperature, 25% of the original nitrogen was consumed. So the nitrogen originally was half. 25% was consumed. 6.2 for 8 marks. Calculate the case C. Now, there are many ways of doing this thing. Have you been taught the rice table? Or there's some teachers call it ice block. What do you all call it? Rice. There's no rice. Rice is what you eat. You must write the word ratio, initial conc, changing conc, equilibrium conc. You don't just write E, I-C-E. I don't know what that is. Is that clear? Initial concentration, changing concentration, equilibrium concentration. So we need a big page here. Let's see. Yes. So the ratio was 1:3:2. Nitrogen, hydrogen, ammonia. Now, in our case, before we start, I am going to work in concentrations and I'll tell you why. The examiner gave me the question in concentration. Can you see it? Can you see concentration there? Mole per liter. Mole per liter. So I'm leaving my table in concentrations. I'm not changing it to moles. You can change it to moles if you want. Then you change it back to conc. So I'm going to leave it in concentrations. So you write initial concentration, change in concentration, or delta C if you prefer, right? Delta C. Equilibrium concentration is square brackets. There's your I, C, and E. Square brackets means equilibrium. Then you bisect this thing into 3 parts. Initial, change, equilibrium. Now before you do all this nonsense, there's 9 blanks. The first mark out of 8, you write your KC. Products squared, do not write products over reactants. Products squared, only gases, make sure these are gases. Products squared divided by hydrogen cubed, concentration of hydrogen cubed, times concentration of nitrogen to the first power, hydrogen cubed. Now you got 1 out of 9. You must write your KC expression. Now we go back to the English. Initial concentration of nitrogen is half, and initial concentration of hydrogen is 1.5. So hydrogen is 1.5 molarity, and nitrogen is half molarity. And at the start of any reaction, you got no products. Your test tube is empty. Before I fill this blue liquid, there was nothing here. So at the start of a reaction, there's nothing. Got it? Now we're going to look for one more. If you fill only one blank anywhere here, you can walk out the whole table. Only one number you need. So we need to find it. And now we get caught. When equilibrium is attained or reached at a certain temperature, 25% nitrogen was used. Now let's work that out. 25%, and the nitrogen was 0.5 molarity times 0.5 moles per liter. What is 25% of 0.5? 0.125 molarity used. Where does this figure go? Because I have 1, 2, 3, 4, 5, 6 blanks. Where does it go? Which change? There's 3 blocks for change. First column, because it's a decrease or change in nitrogen. Now you see, you learners have to do similar things like this in the trial. You have to work out some figures first and then put it in your table. You know what you guys did? You all never showed this working. You all left this thing out. You all went straight to the table and put that value like a magician. We don't know where you got that value from. So we took out marks. You were marked down because somebody can copy this from their friend next door. Now you treble. This is the only row. The change in is the only row you use the ratio. 0.125 times 3. What is the answer? 0.125 times 3. 375, 0.375 molarity. And here you double it, 0.250. And then you put minus signs in pencil here, because these are reactants. This is a product. You subtract those two, but add these two. In pencil you put the signs. This minus this, 0.375 I think. 1.5 minus 0.375 is 1.125. Yes. And this one you add. And now you take these 3 answers and put it in your KC. So you say KC is equal to 0.250 squared all over hydrogen, which is this one, 1.125 cubed, multiplied by 0.375, and whatever the answer comes out to be. Right? Whatever it comes out to be. Anybody knows the answer? Worked it out? Put all this in the calculator? I had the answer here, I think. Just let me check. Yeah, it is. Is it here? 0.117. A very small Kc value. Kc is less than 1. So low yield. They may ask us in the exam, comment on the yield. If this answer is less than 1, that means your reverse reaction being favored. Very bad. You're getting too little products, you got too much reactants. It must be greater than 1. Low yield. Okay? Right, next. Let's look at your booklet. Before you all look at your booklet, I want to look at mine. Right. I know you all had a question like this in your exam paper recently. I want you to take this down, please. Take it down. I'll give you a few seconds. Right? The online people can try and solve it while these people are taking it down. A grade 12 learner finds sulfuric acid of that value with a hazard symbol. Now the hazard symbol is easy. What precautions will you take when you see that kind of symbol in that triangle in yellow? Very simple, right? It is corrosive. It means the acid is corrosive. it's being poured on somebody's hand there, right? There's somebody's hand there. So it's corrosive. Wear gloves, okay? As the acid is corrosive, that's one. And number two, right? When diluting this acid, always add, is it water to acid or acid to water? When diluting. It's not anything. Acid to water always. When diluting the acid, always add acid to water. Okay? Right? Now, 8.2 is the question that I'm worried about. Calculate the concentration of the acid in the bottle when the examiner gave you the pH and the volume. That's all. The pH and the volume was given. I want you to find the concentration. We know concentration, C equals N over V. But we don't have anything. We haven't got C, we haven't got N, we haven't got V. So that's out. But we got pH. How can we use a pH to get us the concentration of the acid? And this is the problem. Many of you don't do this. Step one, ionize the acid. You have to write this equation for all acids and pH. Any pH calculation must have an ionic equation. If you don't have it, you fail that paper in the trial. You got it wrong. And I'll show you why you got it wrong. Remember, these are concentrations of ions. There's the concentration of the acid here. Number two, the ratio is 1:2. Isn't there 2 hydrogens here? You must balance it. So, the concentration of the hydrogen or hydronium ion is double the acid. So if you work out the acid concentration, if you want this, when you find this concentration, to go back there, you got to divide by 2. If you didn't balance the equation, you won't divide by 2. You get it wrong. Do you understand? So let's work this out now, ladies and gentlemen. Please write a balanced ionic equation for pH calculations of acids and bases. Because this is monoprotic. No, it's diprotic. It releases 2 hydrogen ions. So this concentration is double that. If this concentration is X, this one is 2X. Please make yourself familiar with this kind of thing. Right? Au fait with it. So number 8. Noise people. We're almost done, don't worry. We'll go home and relax. So we say pH is equal to a negative log of the hydrogen ion concentration. Some learners put their own things in this bracket. It's in the data sheet. You write HCl, you write OH minus, all wrong, not. We stop marking. The pH was 2.2 equal negative log of the H plus ion. Now you work up the anti-log of this with your calculator. What do you get for this? The H3O plus ion B, 0, comma, I think I have it here. I think I have it. Is it question 8, people? Okay, you give me scientific notation. Yes, give it to me. 10 to the minus 3 moles per liter. Now, you may be wondering why I write capital M. Right? Capital M is called molarity. Molarity is a short way of writing mole per liter. Now, why do I do that? Right? I try to help the learners. See, mole per dm cubed. This unit is the same as that. Now, let me explain something to you. Capital M is the same as this. 1, 2, 3, 4, 5, 6, 7, 8 things to remember to get this unit right. Concentration. Now, if you forget that full stop, do you know it is wrong? Did you all know that? If you forget that full stop, I mark it wrong. Now, if you use capital M, that's the only thing to remember. You can't get anything wrong now. You put plus 3 here. It's wrong. There's no such thing as doing plus 3. Wrong. capital M, or write the word molarity, full marks. Choice is yours, people. If you were getting this marked right with no dot, I'm telling you, end of the year, I'm marking it wrong if I mark it. You got no marks. So be careful. Right, this is wrong, by the way. Remember, the ratio is 1:2. This is 6.31 times 10 to the minus 3. The sulfuric acid is here. The ratio was 2:1. There's H plus is here. So you take this answer. So concentration is equal to that. Divide by 2. Right, divide this by 2. Concentration of the acid. Now what's the answer? Divide by 2. I don't have that answer here. No, I don't. What's the answer, people? Divide this by 2. 6 divided by 2 is 3. 3.15 times 10 to the minus 3. Or 16. Right, there's the answer. That's the concentration of the acid. Please note. Please remember this. The concentration of the acid and the concentration of the ions can be different if the ratio is not 1:1. Please remember this for the final exam. The same with bases. You get monobasic, basic bases. This is monobasic. KO. But when this ionizes as a strong base, 2 hydroxides. So the concentration of this is double the concentration of the base. This is a 1 in the front here, but that's a 2. The base concentration is half. This one here, the acid concentration is half the concentration of the ions. Please make a note of it. And the other thing, even my work here today is based on the log of the H3O plus ion, because this was the pH of an acid. Can they ask you pH of base? Yes or no? Yes, they can, and you cannot start like this. A pH of a base, you end with this. You have to end with this. You start with this for pH of base. pH of base question, let me just write it down and show you. When I talk about pH of base, step 1 is the Kw expression. What expression? The Kw expression. When they ask about pH of base, Kw, which is this. Too many people talking. You will take that concentration of the H3O plus and put it here. Oh, sorry. You take the OH minus and put it there. Kw is that. This divided by that will give you the H3O plus. Then you take this. Why this paper is in the way, man? Right. You take this. This is unknown in the base. You put your base concentration there. If you have to double it, double it. Half it. Put it there. That divided by the base will give you the H3O plus. Then you take that answer and then work out the pH and put it there. So the pH of a base is a double step calculation. Step 1, Kw expression. Step 2, pH equals negative log. You've got to find the H3O plus first. Concentration using Kw. I hope I made it clear. This didn't come out in March. Didn't come out in June. This didn't come out in the trial either. So when will it come out? Final. It will be there, I'm telling you. If it's not there, you can find me and give me a slap or something. Right. Now we come to our friend again. Yes, we have a lot of friends. We have this question. You can draw it quickly, ladies and gentlemen. Right? Where we have electrode. Right? Now this is definitely galvanic. So in this one, chemical energy becomes electrical energy. How do I know that? There are two beakers here. One, there's the There's the voltmeter needle. Can you see the needle there? The needle is giving a reading. This is actually a voltmeter. A galvanic battery has voltmeter. An electrolytic battery has no voltmeter there. It has a battery there. Let me just show you. I don't have one there. Tomorrow's exam paper. Let's see if I got a galvanic versus electrolytic battery. Just give me a second there, boys and girls. Right. See? That's electrolytic. One beaker with a power source. No voltmeter there. Of course, I can draw a voltmeter here to confuse you. They might do that end of the year, but you look for this. As soon as there's a power source, electrical becoming chemical. Electrical becoming a redox reaction. Right. Now what you're going to do in your data sheet, you're going to select aluminium and look for chlorine gas. That's the first thing you're going to do. Select aluminium and look for chlorine gas. Okay? And if you look at it, table 4B, right, here it is here. There's the aluminium equation, people. And chlorine gas is right at the bottom. Here it is here. I find it strange people are talking at this point of the year. If you came here to talk, you must please exit the venue. You are disturbing others. I left you for quite a long time now. Now it's annoying. Leave the venue and go study at home with noise. Because some people came from far to learn. You are being disrespectful to those learners. And it's not nice. If you don't want to learn, the door is open, you can walk out. I won't stop you. But don't come here and disrupt other people. It's not nice. It's not a funny thing. We came to work. Let's work. If you don't want to work, the door is open. Please leave. This is not school. You can go. All right. We're coming back to our chlorine. Our aluminium is right at the top. Our chlorine is right at the bottom. Now, as we said, it's galvanic. We always reverse the top equation. So, a smart way of doing this is simply drawing an arrow there and going backwards. If you do this now, don't recommend you do this. This is a shortcut. If you know you reverse it, draw a reversible arrow there and go copy that thing down. Aluminium loses 3 electrons, become aluminium cation. So, we'll start. Al becomes Al3 plus and releases 3 electrons. So that's oxidation. That's the anode. What else we can know? The anode is always negative in galvanic. The anode also decreases in mass in galvanic. Okay? And the electrons always flow from anode to cathode. Now, when you come to this kind of question, all these things, all these statements must be in your mind. Because you don't know what clue that examiner is going to give. He's never going to tell you all 5 things here. Never. Like the clue he gave us in this question, or she gave us. We mustn't say he all the time. Right? The examiners, there are women who are examiners too. Right? If you look at this, the clue that the examiners has given us is, we must select aluminium and a chlorine gas electrode. Now, what you know about gas electrodes, the platinum is inert, unreactive. There's platinum there. It doesn't react. Bubbles of chlorine gas, right, are around this electrode with a chloride ion solution. Now, the chloride ion solution generally is HCl. They may ask you what solution is in the chlorine equation. Take it from the data sheet that you see, right? What is in the beaker where the chlorine is? Take it from the data sheet. And you can see what is in the chlorine gas? Chloride ions. There's it there, Cl minus. And just put here. Easy. The solution, the electrolyte, is HCl. Done. What is an electrolyte? It's a solution that conducts electricity because it contains free ions. Many of you did not write because it contains free ions. So you lost 1 mark. Some of you didn't even say it conducted electricity. It was shocking. But anyway, we learned from our errors in September and we put it right in November. Right? So number 2. Now let's go to the questions. Now that we know the anode is aluminium and the cathode is chlorine, we're going to get full marks. Now this is embarrassing. State the standard conditions that apply to the cell. This also appeared previously. How can you get this wrong when this is the first thing you taught? The standard conditions are temperature is 298 Kelvin. Right? Concentration of solutions must be 1 molarity. And this is a gas electrode. So standard air pressure must be 1,013 times 10 to the 5 pascals, which is in the data sheet. You go and copy that value. Many of you see here, concentration of solution. You'll just put concentration. Remember, this is a metal. You can't talk about concentration of a metal. It's the concentration of that solution. That is aluminium salt ions in there would maybe nitrate ions. That's the famous one we put. The salt bridge is generally KCl or NaCl. Famous. Now, before you answer all this, you must put all this green writing that I've done on your own. You got to do all this yourself. So when you see the question, you can match it to your diagram on your own. Because we know aluminium is the anode. That we know is the anode. We made our selection. Aluminium is a better reducing agent than chlorine gas. Or chloride ion, sorry. Let me double check. I don't want to mess it up. Right? Let's come back here. Elemental aluminium. Let's go to it. Elemental aluminium is a better reducing agent than chloride. Because as we go up the table, reducing ability gets stronger. Right? That's what this arrow, and you can see that arrow is by aluminium, reducing agent. So it must undergo oxidation. All reducing agents undergo the opposite reaction. I think you all knew that. Did you all know that? An oxidizing agent undergoes reduction always. A reducing agent always undergoes oxidation, loses electrons. So aluminium loses electrons better than chloride ions, not chlorine. Watch here. On the right hand side, it's Cl minus. So that's a poor reducing agent, Cl minus, compared to aluminium metal. So aluminium will corrode. Please note, there's chlorine gas. That's called the chloride ion. Or you could say, write what you see. The chlorine -1 ion. Write what you see. Chlorine -1 atom. Better. Correct. Than saying chlorine. Chlorine -1. Correct. Chlorine, that's chlorine. When you say chlorine, I'm thinking Cl2. That is not Cl2. Write what you see and you're going to start getting marks. You mean you guys never knew all this before? You can use the word chlorine interchangeably when you please. Never. You're lying. Your teachers told you that's chloride. Right? So let's go back to our question. Now the question becomes a joke because I got everything right. I know my anode, I know my cathode, I know my half reactions. There's nothing for me to lose or to gain. And you see how easy it is. State the standard conditions. Go on by heart this, it's in the CAPS document. 3 marks. 3 marks for nothing. Is aluminium the anode? It is definitely the anode. Give a reason. Oxidation occurs here. What oxidizes? Al solid to Al plus 3. Because you reverse the equation. From your solid you became a salt. From the solid you became a salt. Show the examiner you know what you're doing. That's oxidation, sir or ma'am. How does the mass of aluminium change? It's the anode. It must decrease. If they ask you, give a reason, the anode is the place where oxidation occurs. Hence the mass has to decrease. Because the electrode corrodes. or disintegrates or breaks apart, up to you what you write. Write the half reaction to support your answer 9.3. So how important it was to reverse this aluminium. See? There, you proved it. Aluminium became Al3 plus. From a solid, it became a salt, aqueous. You show the examiner, hey, I've got it right. The solid corroded to a salt. Anytime you see a charge on a metal, it's called a salt. It's dissolved. Gone. But while it dissolved, it donated 3 electrons, which is a good thing. Those electrons can make a circuit. And that's how we get our battery. Right? Turn over. Write down the following. The formula of the oxidizing agent, it undergoes reduction. So the formula that underwent reduction was chlorine. This is the equation for chlorine. We didn't reverse this. This is reduction. So the agents are always on the left-hand side. There's it. So the formula is Cl2. The reduction half reaction, there's it here. 9.5.2. The net cell reaction, now you need both equations. Aluminium becomes Al plus 3 electrons released. Now aluminium lost 3 electrons, donated it. This fellow gained 2. There's no such thing. You can't lose 3 charges and gain 2 charges. You actually must equalize the charges by finding the lowest common denominator. What's the LCD of 3 and 2? 6. You actually lost 6 and he gained 6. So you treble this one and double this one. So double, that's 6. Treble. 3 times 2 is 6. 3. And then you take equation 1 here and equation 2 and add it. You take equation 1 and 2 and add it. There's equation 1, equation 2. So you say 1 plus 2. And now you get marks. 3 chlorine gas molecules plus 2 aluminium solid, gas and solid, right, becomes 2 aluminium ions plus 6 chloride ions, aqueous. And this is called the overall net equation. You took the half reactions and added it, but before adding, you equalize the electrons. You must balance for charge. It's called balancing for charge. You all know about this? Yes or no? Good. Now your paper had 1, 2 and 2 there. You all just added it. Your exam paper had only 2 and 2. This one, the LCD first, to equalize the electrons, in other words. Right? Please try and put the phases of matter. Aqueous, solid. If it's a salt, aqueous, gas. Chlorine is a gas. Now, the last thing we do is calculate the EMF of a cell. Let me just do it. We got 1 minute. EMF of cell equals E naught anode. Right? The cathode was chlorine. I'll just read the chlorine. I think it's 1.36 if I'm not mistaken. Well, 1.36 minus aluminium is negative 1,66. Right? And if it's galvanic, your answer must be positive. Right? Add these two. What's it? 3.02. I think it's 3.02 volts. Please write the plus sign and tell the examiner when it's plus, it's a spontaneous reaction. That means you can build this battery and it'll work. If the examiner asks you prove the reaction is spontaneous, do this calculation. Got it? Right, we'll see you tomorrow. Thank you, online learners. Thank you, audience. Right? I'll try my best even tomorrow.
So there we go. That was the grade 12 physics session for grade 12 learners in preparation for the final examination. And we've been coming to you live from the Al Falah College in KwaZulu Natal. It's been a bumper pack session today, and we will be having a session tomorrow on chemistry, starting bright and early from 9 o'clock, going all the way to 3 o'clock. Let's call on Khalid. Let's have a chat about the session today, because I think I'm a little bit sharper now with my with us being behind the scenes with this physics session. Assalamu alaikum, Khalid. How is the session been today? Your thoughts and reflections on the inaugural online physics workshop that we are doing jointly with Al Falah. And for Al Falah, this is part of the CSI outreach to empower learners from the surrounding community. What a session!
Walaikum salam wa rahmatullahi wa barakatuh. Yeah, it was quite a session. It was quite a session, When I came in this morning, to monitor, I was sitting there, inquisitive as to how the learners will react. Our learners, most of the time, they seem to they want to drive the narrative, because they are quite comfortable with these workshops from Awqaf SA, and it is something that I saw in the morning today when I came, that the students were buzzing, and some of them were transferred from the workshops that we had during the weekend. I could see the Anele Mofokeng, who was one of those who were constant, on the charts talking to us there. And I'm very grateful as well to Mr. Nikesh. Mr. Nikesh has been talking for 6 hours, and he's
The
been going.
machine, the machine.
He's a machine. He's a machine, and that's exactly what you want, from a facilitator. Because I've been in a class where a teacher, will get a 45-minute period. By the time 45 minutes comes, everyone is super tired of him. But our facilitators here, including Mr. Kota, they are very, very special. They can go for 6 hours. They can hold the initiative, and they can sort of stamp their authority. And that's exactly what you want from a facilitator. And I think sitting here for 6 hours, listening to these sessions, I can do a little bit of physics myself,
Can
because
you make a bomb now, Khalid? Okay, you've been
because
working through it yourself.
I've been
Fan.
working through it myself, sitting here, because the methods have been simplified, and that's exactly what we want ourselves, to be able to benefit, not just to sit here, as a tech guy, but to also benefit from the sessions.
Yes. So, Khalid, are you doing physics as one of your subjects? I know that you are part of the UCT online grade 12 cohort of learners.
I'm not doing physics, but I became interested because the way he simplified
Ah,
it. And I've never sat in a physics class, by the way. So I thought it's maybe an opportunity for myself. So I did write some notes, and I came across, some new terms that I will go and check up and get used to them. And hopefully, maybe by next year, I will say that I'm also a product of Awqaf SA's physics
yes.
course.
There we go. So, look, the one thing, this is our inaugural, our first time that we are hosting this physics online workshop. We have noted some of your concerns and what you want us to do. We have in the past um, kind of heeded or listened to the pleas for people for physics. So this is why we did not hesitate when this opportunity arose. Initiative by Al Falah College as part of the CSI. And don't worry, we are in small increments. We are going to improve on our production to make it easy for you. So here's to your success. Anyway, Khalid, I think that's where we wrap it up. I'll just play our concluding video just to wrap up. But we'll see you on the other side, Khalid. I don't see our video over here. Let me just add it to you. So, Khalid, maybe your final remarks while I get this video lined up.
I think I have this video. I think I have it. But just my final thought is that I'm quite happy because
Okay, go for it. Sorry about that.
I'm saying that I'm quite happy, with the input, that was because we didn't just have learners on the online platform, but they were adding their input, man, of
Sure.
which we did tell them that, look, Awqaf SA has been focused on mathematics, therefore we are trying to add other subjects. So you need to bear with us. Obviously, there will
We
be
are
those.
not perfect. We are not perfect, and we do apologize if anyway you've been, um, it's been a little bit tough for you. Bear with us. We are gonna improve our production and how we present this to you. So yes, Khalid is rightfully saying so, and this is a two-way conversation. We are vibing with you. You are our participant. Your feedback is oxygen to us, and we hear and heed all of your calls. So we are gonna have a reach out there to our facilitator and see how best we can assist you, because we ultimately are of service to you. That's it from my side, Khalid. I'm gonna just conclude with our intro video. Anything on your side? Final remarks?
Now, the final remarks from my side will be that the students, need to tell others that we've got a platform like this, because most people know Awqaf SA for mathematics, but can tell them that we are doing physics, we're doing chemistry. And the main focus for today was physics. I got some few students asking me,
What
why
about
are we
chemistry?
why, why are we doing paper two now? Aren't we supposed to do paper two tomorrow? So I had to explain to them that no, the whole focus for today will be physics, which is why we did paper one and paper two. And tomorrow, the main focus will be chemistry. So we're looking forward to the students to interact with us as well tomorrow morning.
That's where we leave it. See you on the other side. My co-pilot Khalid. Assalamu alaikum wa rahmatullahi wa barakatuh. We'll see you tomorrow. Thank you for joining.